Okay, share. Good. Okay, I think we start now. Thanks all for coming to the first ever FoodOn Hackathon and devoting many of you a good part of the week to it. This is at Wageningen, February 17th, 21st, 2025. And I have a little bit of a cold, but I'll try to get through that without sneezing too much on you. The confluence of events that got us here, periodic table of food curators. We're really eager to have a hackathon in person, and just so happens that ComFocus called me to Wageningen for their end of project meeting. So the two opportunities came together really well, and here we are. So I thought what we could just do is a round of introductions, so we get to know each other, and then I'll launch into a bit of a scoping presentation about what FoodOn is, and then we've lined up some other people to also present. I don't know this AV except to know that there is an HDMI cable and a SVGI and a USB-C, and all of this should come together if you bring up your portable to do screen sharing and get on. I'll keep my computer going. That would be the other alternative, because this way it's captured on Zoom.
Let's not play tech games.
Yeah, okay, good. So Kai will send me his slides, and then yeah, thank you, Kai. All right, so beginning. I guess I'll start. So thank you, Julie, for playing Fraser University, and I came into this support group because I was addicted to food, and started about 11 years ago on this project because we were helping epidemiologists with their line lists, trying to trace food outbreaks and figure out where whether two outbreaks were connected phylogenetically. I didn't realize at that time. I didn't know anything about epidemiology, bacteriology, taxonomy, genomics. So it was all a crash course for me, but realizing things like little foodborne outbreaks are happening all the time in cities. The question is, how far away do they start? And so the whole food traceability question really begs for a food ontology. And just to put it really short, because I don't cover this history in the presentation, we looked around for a vocabulary, an existing vocabulary that would be good to shoehorn into a semantic web ontology, and Langual turned out to be the best candidate for us. Langual started in America in 1975 as a factor food vocabulary. It was put together by a library science fellow who did a great job. And it's got 14 facets that cover food source, organism, packaging, cooking, and preservation methods, and so on. And since the vocabulary is around since 1975, people subsequently tweaked those lists and turned into a pretty comprehensive vocabulary. But it was for food composition. It was for the folks who were looking at a plate in front of them and trying to describe what was on that plate. But what it didn't have, for example, was a recipe model, a model where you could really well describe the components in a food beyond just listing the food sources. So always opportunity for improvement. And yeah, that's all I need to say now about FoodOn in its origins. It actually was taken over by European curators when USDA pulled funding on it in 1995. And then, in a sense, the Langwell folks, the Langwell folks have really welcomed us to be the successors, the inheritors of Langwell in the semantic web. And so that's been a good relationship to this day. Anyway, I think that's enough about me. Just to say that USDA has helped fund this work directly, and their mandates are a bit narrower. It's used to work on the Food Data Central nutritional database, built with all sorts of testing data. But people are like wanting different things out of the food ontology. So I'll try to get into the scoping around that in my presentation. So we go clockwise?
Pick a direction and go.
Go for it.
All right. Hello, everyone. My name is Kai Blumberg. I'm an independent scientist who's just here on my own volition. I may or may not work for USDA, but I'm not here officially representing them. Yeah, so I did my PhD in kind of ontology related disciplines making use of ontologies. So I did it in marine microbiology, but I did a lot of work using ontologies kind of within knowledge graph-like structures to annotate and use it to like annotate data, bring it together, and actually get something out of it. So that's really my expertise. Over boundary stuff. And people contributing to one of the people contributing on. So yeah, happy to answer any questions. Any help on stuff. I'm happy to help as well right now. Thanks.
My name is Nils. I'm from Wageningen Food Safety. I've been in the data science field. I actually started out more in natural language processing, but we started getting into the things we extract from text, the information we extract from text, and started getting into expressing them in a structured and machine interpretable way, which we know the track. So I mean, we are mostly here to broaden our expertise and see how we can create synergies between food safety and people.
Yeah, my name is Jonathan. I'm from the same team as Neris. I got my also a little bit into ontologies since last year, and mainly in the context of trying to connect data sources together and collaborate with different data and using databases and stuff.
Hello, everybody. My name is Jenny Gallo. I'm working for the Alliance Biodiversity and CIAT in Cali, Colombia. But specifically, I'm working for the project, the Periodic Table of Food Initiative, PTFI. I'm working with Marie-Angelique Laporte, that is also from the Alliance, and has been working a lot for different ontologies. When we started this project, the Periodic Table of Food, we had the question about how we can identify foods that we will analyze, considering that we really need to standardize these kind of foods, because we will do a lot of work standardizing different protocols for metabolomics and different omics processes for these foods, but we also need to standardize the way that we call food. Then we decided to use FoodOn as the ontology to identify all the foods that we'll analyze in the PTFI. I'll talk a little bit more about the project, but that's the, basically. So you will see that we use ontologies like the backbone for all the PTFI data. So this is really helpful for us. I'm not an expert at all in good ontologies, but I'm learning about these thoughts. And I think we are doing really great. And we also are working together right now with FoodOn to try to include also some nicks that we have in the project that maybe haven't been considered in the food ontology, and we are really doing some great job. So I'm living here in Washington from today. So it's nice to be here in the university. I'm living here, but not related to the university, but now I'm here in the university. That's great. It's amazing to be here sharing this. And
Hi everybody, nice to meet you. I'm Magali Dever, and I'm coming from France, from the INRAE, the National French Research Institute for Food, Agriculture and Environment. And so I am working with the group, this FoodOn group, since
But in fact, I am a food scientist, and my background is more processing and microbiology or food technology. But I am interested in ontologies and knowledge graphics, machine learning. But since for 10 years, let's say, and I am also involved in my research department in building another ontology, but very close to FoodOn. And so the purpose here is to make some mappings and so on for me, because I am using the FoodX2 reference. And it's very close to Yanwell as well. So that's it. Yeah. Nice to meet you.
Yeah, I'm Anusha Sanger, and I'm from San Francisco University. I have my background in mathematics. I joined FoodOn, I think, 4 or 5 years ago with Damien, and I'm a FoodOn creator, and I work with Damien to just make FoodOn comprehensive and just make sure that it stays up to date. And currently, we're working on enhancing FoodOn interoperability with mapping all the USDA samples and PDF5 to FoodOn just to increase its coverage. And currently we're also developing templates to make it more organized and structured with Damien and Kai, which I think we'll be covering on 3rd or 4th day. So you're all welcome to join the discussion if you want. And it's great to see you all here. Thank you so much.
Anusha is the star of the show, just in case anyone isn't here. Like Anusha is the star of the show.
Nice to meet you all. My name is Santiago Duarte. I, like Susana, I'm also from Academic Research Institute. I'm also in the data science team. My background is more in climate change for resources. So, like you, I'm doing my grad course to learn a lot of things. And I'm really excited to see the connection that we do, connecting with the background of machine learning part of what can be done, especially for the eco-writing project that is the one that I'm touching.
Hi everyone, my name is Cameron McRae. I'm a postdoctoral fellow also from Simon Fraser University. And I mainly do research in food marketing and sustainability. So I'm a bit newer to the ontology space, but I'm interested in using FoodOn to structure and connect a few databases I have access to around consumer behavior and food consumption.
Hey, hello everybody, my name is Joep Dummers. I work for Wageningen Social and Economic Research close by. Ontology-wise, I work on 2 ontologies, one for food consumer science, which I will present a little bit later, and also one for agriculture engineering. I'm an agriculture engineer by training, and therefore I'm also a user of FoodOn.
I'm Felix. I'm working for the National Institute of Public Health and Environment in the Netherlands, but I'm also doing a PhD here in Wageningen, a collaboration between the two. And at the RVM, I'm working on connecting the different data sets we had available about food, using an ontology to create a knowledge graph to be able to say something about the protein transition data.
My name is Victor Speyers. I also work at the National Institute. It was a couple of years ago that we were struggling to connect all those data sets that Felix was talking about food that we have. And I'll say a bit more about it a bit later. And then we came across FoodOn and we thought, oh, that would be a good option, but we didn't know how to get on with it. So then we asked Felix to come and do it.
I'm Jens Wiel. I recently started at the National Institute of Public Health and Environment, and I'm here in a supporting role for both Ido and Felix, basically, trying to get on board with the whole ontology work, basically. That's all you choose.
I'm Kat Martin. I'm an information scientist from the United States. I'm here representing a collaborative project called WikiFCD, which is a open source wikibase full of food composition data. And we have mapped our food items to FoodOn. And I guess in addition to WikiFCD, I'm a longtime volunteer contributor to Wikidata. And so I'm here to work on anything related to WikiFCD, Wikidata, FoodOn, knowledge bases, semantic web, RDF, Sparkle. Anyway.
That's what I want to hear. You're the right person at this workshop.
Hi, all. Nice to be here. Alex, here, over. Background in computer science, technology, from that background, yeah. Often interested in ontologies, of course, like FoodOn. Maybe some of you know, yes, the author of the ontology of units of measure. Well, it's
Good to see you.
Welcome. Yes, thanks, Michael. I was the longest standing person that I know from Waukegan because we started up a conversation on the units of measure over 5 years ago, at least, I think.
we should continue that.
Yes, absolutely. Okay, and yes, Kai's worked with IO2 on the unit stuff, and what we were thinking about. Okay, so that I haven't listed all the FoodOn curators and others. There are a couple of different meetings that we have every so often around food processing. Sometimes a monthly meeting on a specific project, but I'll just say that our team at SFU in and out of the food ontology, but yes, Anusha is the main, my main helper. I thought I would get into, okay, this slideshow, by the way, has a few other slides just for information help in case you need them. So this is about administrative stuff. We're here for 2 days, and then we switch over to this other room, which is on that road, and then about 3-4 blocks that way. Tonight, there's a dinner that the Wageningen Food Safety Research folks have kindly sponsored at the hotel, Fletcher, and that's starting at 6. So we'll probably finish off around 4 o'clock today to give some breathing time, and then get to the buffet at the hotel with the view. And the schedule is a first draft. It's a hackathon, so expecting that we might be a bit flexible, and we still have to sort out what's happening exactly on Tuesday. But so today, Monday, the introductions, and then into some project slideshows to give a project peer-to-peer exposure. Then after lunch, and there's, by the way, I think we're being supplied with coffee and some treats. Ali, who has led the effort to get us here, and organizing the catering and so on, he can tell us a little bit more about how that comes down when he gets in. I understand he'll be showing up around now. Then there is a lunch, and then the Wageningen Food and Safety Research people have got a 2-sectioned presentation and kind of workshop. So kindly being the hosts of this whole event, we will hear what their projects are, EFRA and Eco-Ready, and try to give our feedback into what they've got going on. So that's this afternoon before dinner. And Tuesday morning, a couple of hours to go over roughly what each hackathon thread could be, so you can sort of gauge where your interests are. We actually have to sort out whether this is going to be a linear experience, or whether you know, maybe the slot that's assigned to a hackathon topic is actually just to introduce the topic for those who are interested, but whoever's already working on some other thread can keep on doing their thing. I think we've got to have that flexibility of interest going on. So if there's opportunity to actually create 2 parallel hackathons, that's great too. There should be about 9 of us, 8 or 9, that are here most of the week, constantly. And then we've designed this whole liaison invitee to enable other organizations to get up to speed. So, are there any questions about this schedule? I can say our aim is to record today and the track recording on Friday for the rest of the world to see. But we're not really relying on online presence, and it won't happen Tuesday, Wednesday, Thursday. Okay. One more doctor. Yeah. Say again?
Do you need us to bail you out and do your?
Yeah, maybe, right. No, everything's great as long as I keep my voice, yeah. Okay, so going to do a scope overview of FoodOn, and it's going to touch on the different kind of workshop tasks that we have lined up this week. There's lots more that could possibly be done. We are well aware of our humble situation in terms of the vast world of food. Going to get into the light dive into the different. I've just got some old slides that I want to show that kind of pinpoint the work that's been done so far in some of these topics. And then we've got, we didn't really include the recipe model in this workshop because there's all this other preliminary work that needs to be done in order to situate recipes really well. But there is a separate work group on food processing that hasn't met recently, but would be good, timely to reconvene it. What's going on is I know of at least 3 other projects that are all trying to do ontology-based recipe designs. So it'd be good to talk about that a bit, but I don't think we're ready to maybe. Yeah, we just don't have time. Really, in fact, I'm thinking the next hackathon might be about recipes. If we can talk these other projects into combining energy on it. And then there's going to be one slide on the FoodOn build system and the engineering behind all this. So in today's presentations are not to the hardcore FoodOn hackers. They're to the broader community. And so it's going to be an introduction right now on FoodOn. So in this slide, just presenting the OvoFoundry family of life science-oriented ontologies and how they're interconnected. So this family's been around, it's getting new members occasionally. It's been around for 20 years. And in trying to use these ontologies to describe the whole path of food, the food system from its agricultural wild source all the way to the consumer, you can see application of different ontologies, whether it's ENVO to describe environments, agro for agricultural processes, taxonomy, chemistry, anatomy showing up in the harvested material, the characteristics of things, then finally over to the food product, the kind of food processes going on, and now into drug interactions, disease-related diseases, and then finally the consumer ontology for nutritional studies, and O&E looking at the nutritional effects and benefits or deficits in food. So there's a paper on this if you want to see how a lot of these different things are connected. But I thought I'd take a second crack at describing the scope of FoodOn because we were actually taking in a number of these different ontologies. And so what exactly are we trying to offer in one shell ontology, in addition to lots of our own terms? So we want food material, and it's either coming from some chemical like salt or water. And then we also want to describe organism materials that food is coming from. So there's sort of, this isn't an ISA or formal ontology graph here, but this is actually connecting, roughly speaking, connecting classes of things with the other roles they may play. So there's a question that's kind of often between these nodes. Does this material derive from a part of an organism? So that's the connectivity. And so there's lots of questions that come up around designing. When the focus of your design is on each one of these things, the use case or competency questions come out there, and I'll just show some later. But so that's certainly the basis of what FoodOn wants to cover right now. And then we know there's lots of work going on food hazards, food safety. We'd like to have just a top level description of vocabulary there, but it's up to other people to really detail all of the rules and the underlying differentiate of kinds of hazardous food. So the relationship between a food material and hazardous food may involve some processing to get back and forth between the two states. Something that's ready to eat or needs to be chopped up, otherwise you'll choke on it. Then there's the connection between food material and diets and the consumers of those diets, and the surveys trying to figure out who is a consumer of the diet. And so all of that language should be in one, smooth continuum. So that a food survey can mention the food material directly, do you eat a lot of meat? And then later be able to classify that. And then there's the whole food composition side. The material may be an ingredient in a dish through a recipe process that has some devices, or there's a document or other way of conveying the recipe. And the food ingredients need certain characteristics. So right here, we're speaking so vaguely. We can speak vaguely about eating meat here, but now we move into how much meat, what kind, how heavy is it? Is it raw? Is it frozen? What are the states? And so we'd like a vocabulary to cover that. All of these are areas that we'd like to provide. So there are ontologies that are drawn into this. FoodOn isn't just about minting FoodOn terms, it's actually about minting terms in other ontologies too. We don't get to mint anything in the taxonomy, but nor in Uberon and the plant anatomy, animal and plant anatomies are pretty stable. We don't have to add anything in, usually. Sometimes they miss a term that occurs in another ontology. So that's the case with adding one. The compositional dietary nutrition ontology, which I will talk about a little bit later, covers the nutritionist perspective categories on all of the chemicals involved. Ancestro for culture of food consumers involved in eating. Our focus is here. You'll hear about that a little bit later. Yeah, and then food surveys, ONS, ONE are all about diets. PATO is about those characteristics for the most part. OB gets into the process and the documentation, upper level classes for that.
These acronyms, by the way, are different ontologies. So like OB is an ontology, FoodOn's an ontology, PO is an ontology, etc.
Yeah, so
Ontologies from the
Foundry, yes, so that's one of the other things, to cope with the complexity of the world that we've got out here right now. I am favoring using Foundry ontologies. However, one of the reasons we have our Wikipedia guest here is Wikidata guest is that we realize there's a good opportunity to maybe reuse vocabulary from Wikidata. A couple of criteria, we've got to have URIs that are out there in the world for each term. We can't be using vocabularies where you just get dropped off into some file and have to sort out what's happening. As an example, Wikidata, Wikipedia meet that criteria of being able to pinpoint. So, and they're used ubiquitously. So geonames. So actually what I've done here is added in this diagram some of the FoodOn threads that are actually speaking to different areas here. So usually we'll leave the FoodOn templates description of how we're just putting this raw and most vague terms together for what these animal, plant, fungi, food entities are.
To provide basic descriptions of.
Right.
Those kinds of
To
things.
just talk about taxonomy times anatomy or butchery cut. We need to systematize how we're using synonyms for food materials. There's MIFC, which I will talk about as a hackathon track. ONS merger is a topic that Carl Lechat will help us with because he helped create ONE. And we want to simplify those into one ontology. The food product hierarchy is confusing right now because we have the food materials and then we've got these products. So we want to see how we can at least provide a view where all of that is just smooth and reusable in other people's knowledge graphs instead of getting confused about the distinction there. So I just put those hackathon pieces into this diagram just to show where some of the work is done, but there's of course other opportunities. And then if you're thinking of that each one of these entities is a class in itself, has the right to be studied from its own perspective out into the knowledge graph, then each of them has its own set of competency questions that are focused on that. So organism materials, what taxonomy, anatomy, fresh or raw, preserved, quantity, commodity, what agricultural treatments have been used, where, when, by what organization or farm. So each one of these things can have its own.
Quality there. That's referring to Plato for the qualities, right?
Yes.
Just a detailed question. Okay.
Yeah, right.
Quality.
So I'm just pointing out that, yeah, I could move that question over here. I could put it on that one. But just to say you can speak about a food material without layering on, whether it's what state it's in, or you can get around to specific states.
So you are still wondering like where to put quality.
We have ways of doing things. There's a lot of different things that he's tackling here. So he's just giving a broad overview of possibilities we could talk about. We'll get into specifics like that, how it's being done if we want.
Yeah, and then standards development around that in terms of describing stuff, which is what the MIFC project is about.
Just two other things, perhaps I can switch your question, but here you are describing the world entities, and then we have to dive into the measures and observations of entities.
Yeah,
Again, lots of different people are doing this in lots of different ways. So this is like one way of trying to formalize descriptions of the world using ontologies, and that can work with existing systems, be they institutional or academic, etc. So we can we all have different problems from different places with different mandates and different, ways that we want to approach things. But the point is that this is one way of converging on vocabulary that service multiple of our needs.
Yes, and do you mean that MIFT is an ontology?
No, so my FC is a different project we'll talk about.
Yes, okay, it's a data schema.
Yes, it's a
Okay.
These are tasks, the hackathon tasks.
Okay.
I don't know what else to say. No, I'll just tromp along here. So let's just skim through what's there now for a number of those nodes that we were just talking about. So when it comes to the simplest description of a food item, the most vague, we can talk about Hesperidium fruit. We can talk about a mandarin orange or tangella, which are anatomically Hesperidium fruits. We can add on the information that they're in the taxon Citrus reticulata. We're precomposing this term mandarin orange as a combination of anatomy times taxonomy. And we're choosing to precompose every such food in FoodOn rather than, and it's essential to talk about a mandarin orange to know what taxonomy you're talking about as a differentiate. But now we get into a question of, what else do we add for precomposed terms? Do we add a raw version and have that little axiom, it has quality raw? Do we add mandarin orange dried, frozen, canned? What do we precompose? What do we mint for a unique ID for that thing to make it easy for databases out there to reference these things? Where do we draw the line? Where do we not precompose stuff? Where do we ask people to add on this statement has quality raw for some food? Mandarin orange, an instance of mandarin orange and has quality raw, say, and not have a precomposed group. So that's one of the debates that goes on. I'm being convinced that we should have, maybe not for every fruit, but or food, but that we should have a precomposed term for cooked, where it makes sense, for example. So what does that mean? Well, you've got 3,000 plants, you've got 12,000 fish out in the world. So,
more than.
right, so I've got at least 15,000 terms if I just try to name everything and say what taxon it's in. Anatomy times taxonomy. And then for every other characteristic such as raw, fresh, cooked, dried, we're adding on another 15,000 terms into FoodOn. So that's a kind of challenge when people come asking us. So yeah, so we're, how do you deal with that?
Yeah. Like, what about the raw? I think probably has quality.
Mm-hmm.
It's one of the things that I'm wondering, like, yeah, should I define such a thing like rawness as a property itself?
Yeah.
You're also thinking about that?
Yes.
That's my question.
Yeah, these are classes. These are not like little strings. We get to say under the hierarchy of characteristics what raw is.
We can go over some examples, like details into this maybe later, so like make it really clear what we're talking about.
Yeah, just so one of the core ideas is in FoodOn, we're using an object relation, object property focused view. Everything is a first class entity that can be modeled rather than what you see out there a lot of the time, which is data property oriented knowledge graphs, where you have something and then you name all the semantics in a little data property relation, and then you drop people off to some value.
That's not what you're doing.
No.
It's ontologist anyway. We can look at the details later if there's
Mm-hmm. So Nusha took a lot of time to say, hey, it's not just anatomy that we deal with, especially with meat. They're actually meat cuts that are actually arbitrary. They're not biologically defined the way a steak is cut. And this varies between kinds of animal, for example. Anatomically, we could start to name the similarities, but the meat cuts, they all have different names and arbitrary kind of assumptions. So that was a challenge, but a necessary one if we're naming things.
Or something like that. But just for the arbitrary which regards, we have to develop the spirit class, like nutrients, and which we have to develop primals and primal and regards.
Right, as opposed to cow liver, cow tongue. Those are all anatomical parts. So suddenly we don't have to rely on some custom thing. We can build a template, a pattern template.
After that, another layer, which is the show.
Yes, because different countries have different. That's-
Another layer that's supposed
Right,
to-
right. Right.
And Anusha's done a lot of heroic work on
Yeah, I
this,
mean,
right?
we have to start including the West Cuts probably, but yeah, the idea is
Okay, I'll gloss over the nutrition one, but just to say, from a dietary dietitian's perspective or nutritionist perspective, there's a whole hierarchy of chemicals out of Kevi, which is a big long hierarchy of chemicals from a chemist perspective. So we need these kind of different slices on the same content. Here's hazardous foods. We just wanted to go this far. We don't want to really do any further work, but to offer these categories, higher level categories. So physically hazardous, biologically hazardous, diets. There are different people aiming to do the recipe diet food connection. Just axiomatize what diets do or do not include, and that does seem like a good opportunity for owl logic. Characteristics. Pareto is the main place in OvoFoundry to find characteristics for things. So any material entity has these possible characteristics. So temperature, shape, age, odor, color. Some more specific characteristics. Organism material, we can start talking about biological sex or age, viability, alive or dead. Food material has also some connections, specific characteristics, flavor, tolerability. The idea is to put them in Pareto rather than have them in FoodOn. Sort of just conveys that these are more general characteristics than something that are just going to cook up from my own ontology use.
The point being that all of the foundry ontologies are meant to work together in the way that you reuse terms from someone else's ontology that's not in your own scope. So FoodOn is not trying to own all qualities. Pareto is doing that. So as a matter of reciprocity, FoodOn would ask Pareto to mint the term for them and then would import it back into FoodOn and be able to use it for themselves. That way, if someone else also wanted to use the quality in a different ontology, they could easily use it that way, not the way that FoodOn had the quality, but rather like we know exactly where to go for qualities, characteristics, etc.
And that's the ideal. I won't deny, though, that because a lot of people are volunteering on all of this, that response may not be fast.
Yeah, different projects have different contributors. By the way, all of these projects, every single OvoFoundry ontology project is literally open. That's what the O stands for, the Open Biomedical Foundry. So that means all of you, everyone in this room, could, if you wanted to, contribute to one of those ontologies. That's the end of this action. Just take that away with you.
And just a point, would you remind the scope of OBI also, because it's not clear from my perspective, because I was thinking of more laboratory processing, and
Yes.
now you're mentioning organisms.
Yeah. Yeah, right. So OB, Ontology for Biomedical Investigations. I'm on that curation committee. We meet every Monday for 1 hour to talk about terms. The reason OB finds its little fingers in other people's ontology space is because it was one of the oldest ontologies, and it tried to take on material transformation as well, tried to take on information, documents, data item because it needed all of that stuff. So those terms ended up being there first before being in some pure specific domain ontology. There is an IAO, information artifact ontology. That one basically doesn't have an editorial committee anymore. So OB is sort of taken over trying to maintain any.
OB is kind of like the catch-all for things that don't have elsewhere. A lot of people, not every time, but oftentimes that ends up being the case.
Yeah, so not, its big claim to fame is assays. It's got over 4,000 assays, basically any kind of testing procedure where you're looking at some material and you're trying to get some information out. It'll have an assay in the biomedical area for that category. Yeah, so FoodOn has some food characteristics right now that we would actually try to add into Pato. And the Pato folks have said, for example, that their curation team is really minimal. We have to make a pull request with the exact changes we want, and that's what gets the changes in the door faster. Okay, so mapping, just wrapping up now, mapping. Having done all of this work to describe each food source, the anatomy, the taxonomy, some characteristics, we feel like we'll be in a good position to be a great mapping nexus between the different vocabularies out there, such as FoodX to such as Agrovoc and others. And our first attempt to cover this space is with the USDA. That's our legacy set of foods, sample names, making sure that we can cover those in as pinpoint detail as possible. And so just touching on now, we've so far talked about a very static view, everything in the FoodOn ontology around nutrients, diet, is a vocabulary that doesn't require some kind of focus on processes. But anytime we get into food transformation, and this is the recipe territory, then we really have to focus on how to deal with processes in OWL ontology. And the little logical issue, which one wouldn't think of when one walked into ontology expecting it to do everything, is that the ontology, any ontology you have has to, when you hit the reasoning button, has to come out consistent. Can't find any contradictions. That means no two statements can be present to contradict. So if you're trying to model, say, carrot peeling, here you've got a plate with carrots without peels. Here you finished your work. Here are the peeled carrots. Here are the shavings. If in one, the carrot has part peel, and then the other carrot not has part peel, those two statements contradict. They cannot be true at the same point in time. And so this is where we get into the ontologies that are 3D ontologies that have no sense of time, and all of their statements go into one bag, and then the reasoner goes and looks for contradictions and tries to be helpful and tell you that this can't be true at the same time. That's a 3D ontology problem. 4D ontologies promise to solve that by attaching time to each statement, such that the peeled carrots and the unpeeled carrots are at different points in time. But we still get into problems of identity. If you're on the factory floor, you're trying to trace something, but it's being changed and parts are being added. You kind of have to deal with that with identifiers that track what you think you want to have referenced as the same thing. The carrots that start in a pile, the carrots that are measured out, the same carrots, they're now peeled, and then finally the carrots that are chopped, as all being the same. You have to add an identifier through your factory floor, through your kitchen. That's the only way a robot can follow these materials. And so that's what I call the robot level of ontology analysis, sort of the bedrock or the acid test of your modeling.
However, you should have some time in your graph.
Yeah, so this graph doesn't mention time at all. But each one of these processes has a start and an end and a duration. Sometimes they have restrictions, a minimum duration, minimum or start during the daytime, or all these other restrictions can be added on anywhere you see a blue process box. Meanwhile, these things are the things that have characteristics. Okay, I just wanted to just touch on that and the notion of using, if you have some material that has a characteristic, whether it's a categorical kind like sex or color, or whether it has a scalar kind like mass. Believe it or not, OvoFoundry is still making up its mind on exactly how to represent that. A few attempts have been done in the past. Yeah, and that's the question. How can we create something that enables mapping to these different ways? So the
It's
very
also not, it's not right of us to say there's one way that you
Yeah.
must do it, right? Everyone's doing things their own way, so it's best to bridge between what we're doing and when possible converge. That's also the aim for this workshop.
that's a problem that's coming up. That one group wants to assign project time to the mapping of upper level ontologies so that conversion can happen more automatically. And then at the same time, sort of a rock bottom semantics, so that anything you have expressed in your knowledge graph can be translated into another through some kind of rock bottom minimal or maximal description. Anyway, tomorrow morning, I'll talk about the current FoodOn curation. Yeah, what we do have in FoodOn right now involves these blue command line commands from the ODK, usually from the ODK Ontology Development Kit toolbox. And they're delicately prepare from a set of input files the final release files. And there's a whole bunch of little options that you can tinker with. Having tinkered with them, this is how it's all set up. And I'll get into that tomorrow morning. But suffice to say, we're trying to simplify it a little bit during the workshop. Merge all of these into one file, maybe. Each.
So this is quite detailed, but these
Yeah.
might be things that we come up throughout the workshop. So if anyone has a particular interest in this, please help us with this part.
Each task may touch on one or two vehicle files involved in this. We'll actually be adding one more new file at least.
And also we'll be helping document this a bit better. So that people here who are not familiar with this process are perfect to help us improve the documentation. Because if you can understand it, not knowing what it is, then that means you can help others understand it as well. That's another important thing that we want to participate with.
Friday morning, there's an hour at least dedicated to documentation, where we could collect all the wish lists and the errors and the
Pain points or things that aren't clear to you guys as a new user, for example.
And I should say, I'm not happy that it's this complicated, but it's what we have to live with right now. Okay, and that's all I wanted to say. Okay, so according to our schedule, we can have all right, so going through to 10:50, right? So I think that means next up, Kai. Oh, no, sorry. PTFI, Jenny Gallo. So do you have something you can send me and then I'll pop it onto the computer? or link.
You can share on Zoom. Your computer. You could do that too, potentially. Would that work, Damien? Or
Say again?
if she shared on Zoom, or is it easier if she just emails you? Like you can
Share on
email
Zoom,
by
yes,
us.
you can share on Zoom.
Both should work.
Yeah.
Unless you want to like come up to present it, but it's up to you.
So I'll unshare. It's stop sharing. Okay. Right, so if we're doing the share on Zoom, then log into that link that's on the organizing doc. Yeah. Oh.
And then Zoom meeting, and then we should get this share screen. Hopefully.
Okay, so that means
Okay, we're getting it double, we're good.
I think it's okay.
No. Yeah, are we getting any double? Are we good? I think we're good.
I think so.
All right, take it away.
Okay, so as I mentioned, my name is Jenny Gallo, and I'm working for the Periodic Table Food Initiative. So I will take these 10 minutes to try to explain you a little bit about the use of FoodOn for
Mute yourself. Okay. And then Damien, can you turn off yours? Just so that she's.
Is good?
Yeah.
Okay, this way the recording will Peter.
Okay. Nice. So I will start just making a small introduction about the project. So the Periodic Table of Food Initiative is an initiative to mapping food quality to improve human and planetary health. So basically we have three main questions. The first one is what is in the food that we eat. So we are working on trying to understand the different biomolecules that are in the food that we eat, but also how does the composition of these foods varies depending of different conditions, like how the food is grown. So we're also working with, for example, trying to identify different farming practices in the field that can affect the food composition data. And finally, what are the implications of this variation for human and planetary health? So these are like the big questions that we are trying to help to answer. We are doing this through our global ecosystem. So basically, we are just an initiative that is helping, well, it's not just, but we are an initiative that is trying to help people around the world to use different technologies. So we are not doing the work alone. We are doing this in a network of partners around the world. So basically, the first idea was to have at least one institution per each of the continent in the world. So basically, it's interesting because Wageningen is one of that institutions belonging to this global ecosystem. So here we also have one partner. Actually, it's in the building over there. It's Robert Holt, one of the persons that is leading Wageningen inside PTFI. So they are also doing metabolomics, lipidomics, and other technologies inside the PTFI global ecosystem. What this actually means, and is that, as you probably know, in some of these technologies, there are a lot of problems in get the same information. We are getting metabolomics, for example, from different foods around the world, and we are getting different information. So one of the first approaches that first studies that we did is that we took an apple, we split it, and we sent it to different places around the world, and we received totally different metabolomic profiles. So PTFI is we have standardized and created some protocols to share with all these global ecosystem and try to get the same information. Then from this, basically we have built and we have launched the Marker Lab food composition database, in which we already have 500 foods. And the idea is to grow up along the time. And basically we are like using standardized field data collection, standardized protocols to collect and process the food, and standardized multi-omic tools to finally have all that information in this food composition database. And all this is based on the collection of standardized metadata. And here is where FoodOn, it's a key tool for us. So here I'm showing all the core metadata that we have developed. So everyone in the PTFI ecosystem will collect exactly the same metadata for all the foods that they will analyze. So basically we have like 3 groups of metadata. The first one is collection event, so where people is collecting that food. Even if it's in a supermarket, they will have to collect that data about the supermarket in which you are collecting the food. Second one is about food specimen, and third one is about food sample. Here we have these 2 levels that are important for us, and specimen is basically the food organism information, and sample is the part of the specimen that we are analyzing. And here is, for example, could be one part like leaf or root of the different samples, or could be a process, for example. So a specimen could be raw, but sample could be raw, cooked, dried, and so on. And here I have highlighted like the different metadata elements that we are that are aligned with different FoodOn terms. So for example, specimen food product name is directly the IRI from FoodOn. So we are mapping each of our specimen food products to an ID from FoodOn. We are also mapping the scientific name using NCBI, that is also an ontology and is linked to FoodOn. These are specifically the metadata related to FoodOn. We are also doing this for sample. So for example, like this example, we can have specimen will be just carrot, and we will look for carrot in FoodOn, and we will have an ID. But we will also have root, and we will have leaf. And we are looking specifically for FoodOn IDs for root and also for leaf. So I will move to show you an example of how this looks in the real life. Like we already launched this database, and I will show you what I mean about this. So you can go to PTFI Market Lab. It's open to everyone. We already have 500 foods, 5,000 quantitatively measured analytes, and also we have 40 standard metadata fields working in that database. So you can do a search by food. You can also do a search by compound if you are interested in some specific compounds because you are studying anything in your food. You can go there and you can find all the foods that have reported that compound. So in this example, for example, I looked for strawberry. So here you can see the results. Here we have the strawberry. So I will click in this strawberry raw, for example. Let's say that I click on that. And what I get is, of course, food composition data. So I have here protein, fiber, carbohydrates, and so on. Something interesting is that you can see here in the upper side, we have all the food ontology hierarchy. So all our database is based on the FoodOn hierarchy. And this is so interesting because we can also see the food composition for any of these groups. So I can go, for example, for berry food product, and I can see like the average of the food composition for all the berry food product. And we can compare, for example, my strawberry against all the other berry food products. So it's pretty interesting for us because we are using all this hierarchy to build our database. We also have here, for example, the FoodOn link, so people can go and click and go directly to the FoodOn website. So here I can show you this is all the metadata that we are collecting for each food. And here you have all the FoodOn hierarchies IDs. You also have the link for FoodOn. It's the same for also the species that we are linking. You can go also to the different species that you want to evaluate. And here, for example, I clicked on the berry food product, and I can see, as I mentioned, all the values for very food product, but I can also see all the other different berries that I can have, basically using FoodOn hierarchy. And something interesting that it's part of the discussion is that here, for example, we have frozen, dried, raw, in some cases cooked. Why is this important for us? Is because I can compare all the raw products. So I can compare, for example, all the different potatoes raw, and I can select that in the database and I can compare and have C-scores for that. So I can know for any specific compounds if potato raw is has different concentrations compared with potato cooked. So for us, it's pretty useful to have this hierarchy considering these different food processes. We are building the database in that way, so that's why we want to include cooked, for example, as part of these pre-composed terms. Also, we can use this like post-composed, but we cannot implement it in this hierarchy. And for us, it's pretty interesting to compare and use all these linkages between the different food products. So I think this is the last interesting thing that we can do here. We can do a lot, but this is just like an example for you. Here I have, for example, strawberry raw, and I'm comparing the strawberry raw with all the berry food products. And I can see here which compounds are higher in the strawberry compared to other berry food products and which compounds are lower compared with the other berry food products. So we can do also this for raw, cooked, dry, fresh. I understand that it's difficult to do it for boil, microwave, pressure cook because it's a lot, but we definitely want to maintain these big hierarchies to continue doing this kind of comparison. So as you see, FoodOn has been very useful for us. We are really working hard to map all our PTFI foods into this hierarchy. Yeah, I think that's pretty the work that we are doing right now. So thank you very much. It would be great to have some question for you or comments.
How do you select this kind of products that you have included into the base database?
Well, as I mentioned, we are a global ecosystem, so we have like several different strategies. For the first 500 foods that we have here, it was just based on US food, basically because of permissions, ABS restrictions, and all these kind of things. And we were trying to collect like the basic products or the most consumed products in the US. But because we want to include diversity around the world, we are working with all these centers of excellence, and they can select their own foods depending on their own projects interested. So for example, from here, I know they have some potatoes because here Wageningen work a lot on potato, the different varieties that they have developed. They also have some processed food because they have already some processed food projects. From Colombia, for example, we have some tropical fruits projects because they are interested in actually evaluate the diversity of Colombian tropical fruits. We also have some beans project there. In Thailand, they have like their own local foods and a lot of insect, fungi from Thailand.
That means it comes from your partners, so they
Yeah.
have the choice to include the product that they are working.
Yeah, because PTFI doesn't want to be like a project per se, it's an initiative and it's supporting all the other labs.
So what you are doing is to standardize the way you are analyzing things and structuring.
Like she said at the beginning, you send an
yes.
apple to like 12
Yes.
get back to
Yes,
the
it,
world
because
just
it's
based on
yes, but because you are pointing to the diversity.
Yeah, it's so difficult if we try to analyze all the foods around the world. It's easier to give support to all these centers. Anyone could join PTFI.
Yes, but
like
the real point is to compare variety, to go to the very fine level.
Yeah, and that's why also we want to use this kind of approaches, because if this project started, we created something called the foundational list of foods. So we collect food from experts around the world, and we gave them some instructions of which information we want to get from them.
Yes.
And we didn't. We just get a lot of different information. In some cases, they include the variety. In some cases, they just include the scientific name, different formatting for the scientific names. In some cases, I just received like blueberries. What is that? It will depend of the country.
Yes.
An orange for me could be different to an orange from you. So I have to go and look for a scientific name for that specific variety. We also have a lot of different varieties in some cases that we want to include in FoodOn, and it's difficult because NCBI is not considering varieties. So we're trying to deal with all that variation. But yeah, it's important for us to have some system of standardization because we definitely want to compare all the foods that we have in the database, and we are getting information from different places. So it's pretty important. Just to mention, we are also using, or we created a farming practices metadata module to try to also collect farming practices in the field. And we are trying to link agro, the ontology for farming practices, agro. And Marie and Angelique developed this.
agronomy.
Agronomy.
Oh, agro. Yeah.
Sorry for my Latin pronunciation. So yeah, we also want to include this agronomy ontology into the
Because there are so many factors to take into account. And it's just like for microbiology, or you have the biodiversity databases, so you have to have many information from the environment. So it's quite the same.
Yeah, especially because if you request all the partners to collect more and more data, they will say like, no, it's too much. We are right now we are dealing to try to collect all these core metadata, and we are really helping them, like training them, onboarding with all these metadata to try to be more standardized.
So the very next mission is to add the varieties in somewhere. And after this 500, you still have a next batch or something like that, samples, or does it come like after time to time?
Yeah, we don't know. That's the thing. We don't know which food will appear in the database. So we just receive, right now, for example, we receive a lot of food from Mexico, and they have a lot of nopal varieties and fruits, and something like spiny chayote. So like
But you need to know exactly what you will have. It's only a matter of complex. So what kind of information is very crucial to that's it.
Yeah, that's why we give this metadata format to them, and then they have to collect at least that metadata that we think will be useful for us to define the variety, the species, the cook process, and all this that we can use to map the food on.
I know it's in the people plans to part of the maybe the quality of the product, same product but different countries. Yeah, but when you will compare it, yeah, you have to be more elements. Yeah, like the agro and everything. Otherwise, you compare two products directly and then you have to generate too many issues from the socio-economical part.
Yeah, sure. What we are doing is just giving all the metadata, and then when you are comparing, you are aware of which are the. Yeah, actually, something that we are just implementing, and I mentioned to Damian, is like the local name, for example, and also a tag, language tag, because in some cases, for example, avocado is in English, aguacate is in Colombia, palta in Mexico. So if you will look for palta in the database, you won't get avocado. But we need to, that anyone who is using this kind of language can get the same thing. Or if I'm comparing aguacate, I should compare with all avocado, aguacate, and palta at the same time. So we are trying to also include all that variation, even in the language. Local name could be different, and the food could be the same. And in the opposite, the common name could be the same, but actually the food is totally different. So we are trying, and we are really working hard on trying to include all that variation in the database.
Have you already collected a lot of that information for the current products?
Yeah, we already have 500 foods.
Yeah, so my question was then, have you already tried grouping them and seeing whether the variance decreases or things like that?
Yeah, we have a lot to do and a lot of data, and we had a challenge. It was open for everyone. It's closed right now and it's finished, but that challenge was kind of call for people to play with this data, and we received several projects very interesting, comparing even using food ontologies. One of the projects I remember, it was about finding like nutritional markets for each of the FoodOn categories, and they compared the different FoodOn categories. It was pretty interesting, like which nutritional components are more common for each of these ontology groups, and so on. So yeah, we are trying, but we are not really right now playing.
Yeah, I can imagine you can play a lot with this kind of data if you collect all the data across the world and also the metadata about it.
That's the idea. But we are on the way. We are in the third year of this project, and I think we have set up like all the platforms, and we are starting to the next phase that is actually start working with the data and making analysis and this kind of things. It's open, so if you want, you can play around with this data.
So I was wondering, you said that some of your metadata sections already were connected to FoodOn, and you say, for example, data from Mexico is coming with a lot of local foods. Do you map to FoodOn entities automatically when you receive that data, or do you manually map to them yourself? And I know by experience that you can see strawberry in different places in FoodOn. How do you decide which URI or which entity to choose?
We're right now doing it manually. I'm doing it, so that's why I'm here. I'm learning, and we are also getting like a lot of challenges, because in some cases we don't have that food, so we are working with Damian and Anusha to request that terms. We also have a lot of tropical fruits that are super weird, and in some cases we even don't have scientific name. for that species reported in NCBI.
So far you are sticking to the general category, because as far as I know, there is no varieties into FoodOn.
So, all this discussion has
Yes.
illustrated why we're having this hackathon,
Yes.
and why about four
Very
of the
important.
different tasks are actually
But
directly
it was
related
very
to,
interesting to know that you are giving average value at the general category, and then you can compare things. It's very useful.
Just short answer to this question is that at the beginning we were saying, no, it's too much, too many varieties, so just use scientific name. But then we realized that varieties are really important at different foods. It's totally different mangoes, taste, structure, texture. It's totally different between the different mango varieties, potato varieties. So we definitely need to include varieties. So Damian and Anusha are helping us with that, and we will discuss a bit more about that.
Yeah, this week we'll, you can't go to the FoodOn website and really see policy, curation policy. There are a few notes and things, but what I'm hoping one of the outcomes this week is that we actually create amongst us here curation policy around the varietals. You're painfully aware that NCBI taxonomy apparently only has scientific names for things that have been sequenced in some way. That's what I heard.
That's the way it works, yes.
Is that right?
Yes,
Is it
it's
really
the,
like-
it's the National Library for Biomedicine, whatever, and it's only to serve that genetic repository. So when they get sequenced in, they mint an ID for that organism that was sequenced.
Which on the one hand is amazing because it's such a big taxonomy.
But you have to be careful. Be careful, because there is a genetic variety and the cultivar point of view.
Yes.
So it depends.
Yeah, so, one of the things to investigate here is there a curation where maybe it's not FoodOn that's taking on all names for these tribes, maybe it's Wikipedia or Wikipedia. Now we have to learn, is it easy to hand over the term to Wikidata for a new variable? I know how to do Sparkle query and all the Apple varietals and the great varietals now.
Because cultivars are already registered, because you have, but it is not in the taxonomic level, but it is when you want to sell a new variety, you have to declare it and to register the variety. So the catalog is already in place, but you have to link. There is different places.
Yeah, the
You have
thing
to-
is that not all the varieties.
And not all have been registered.
I was looking for USDA and I can find some of them. I can look for also gene banks and I can find some
You
of
can
them.
have some in
It's
sample
a hard,
also, because there are
hard
some
task.
catalogs.
Yes.
So we'll
But-
get into the details of that task.
Yes,
on the
it's a
varietals.
huge question.
That's going to be an important thing.
Yeah, how do you do it? Because right now, faced with this onslaught of PDF we've been putting them in FoodOn directly, but I realize that's not too sustainable. Although, suffice it, some projects have said, hey, we will do the work to put those rods in wherever they go, whether it's FoodOn. So,
We will continue to discuss.
yeah.
Okay, thank you.
Thank you.
Yeah.
So,
Is the purpose of your initiative to get sort of gold standard for the nutrition?
I think I will say both, but it's the first one, I think, like trying to get these gold standards for some of these processes, especially metabolomics. I will say that is one of the most challenging ones, but we also are helping people to, like run all these platforms in their own food. So also knowledge support, like we are also helping some academic people to learn about all food composition database, about how it works. So yeah.
If you want to analyze whole foods again, using protocol flow, there's a lot of if you're not using protocol.
Yeah, I think that's difficult because it's not comparable, at least for metabolomics, it's not. So the information that is already run in several foods is not comparable with the information that we have. So that is one of the main objectives of this project. And we are saying, for example, to you, like, hey, would you like to be part of this initiative and use our protocols, and then we can compare your data with our data?
Yeah, that would only be data that I'm collecting from now on, whereas you won't be able to use data.
Yeah.
When your mouse is on.
And I was wondering.
That's the 12th.
Yeah, yeah.
12th.
No, but like, I responded to it. No, is it not there?
No,
No.
on Damien Dooley at SFU.
Oh, I think it wasn't.
You went to the
Zoom
other one?
thing.
Oh, here we go.
Yeah.
Okay, good.
Yeah, go
But
down.
we're actually
Oh.
getting very good
Yes, that's
results
first.
because we are also using the same standards, the same
Do I have time to try to cut them off, or should I start, or if we just get to do whatever you want? No, I mean, like, how we.
Oh, I think fine.
processes.
You-
And we are getting kind of very similar results. So for example, I'm not in that analytical part, to be honest, but I'm sending like a carrot and specifically the same products to everyone, and they are getting very good results compared with all the other labs.
You have made some inter-lab comparison. But perhaps it's a good idea to think about the different characteristics of your protocols, so you can have some information to know if you can compare some data from other.
Yeah,
or not,
I will
or
say
it depends on the degree of precision you want to have, because something you have to also sometimes some merge data or average value are also useful, so you can also discuss support.
Just so you're aware, this is the MyFC topic and we'll have.
Yes, it's fine.
yeah, I think
We
it's
will continue this discussion.
could be interesting, but it's not right now in the scope of the project. And we also have a lot of challenges right now. We know this is not easy, but yeah, I think we are doing
On
some
the good way.
Yeah, I think so.
Like I would really like to see more the efforts with MyFC USD one day. So we'll talk about that.
Okay, so next up. Kate Norton on Wiki Food FCD.
I'm here
And
to log in.
we have a break scheduled for 10:50. We can easily move that up to 11, whatever. So, well, no pressure on that, because we're going to want questions and so. So you can take it away from here. Okay.
And if I
Oh, it is right. We need to add the sound back. Oh, sorry. That. Come on. Just. Okay, it isn't. It's unmuted. Good. So. Never. Two.
And do you have any tips on how to move down a page?
Okay.
Okay.
Oh, good.
The arrow button. Cool. Thank you.
Great.
Okay, I'll start by saying that this is a collaborative project, and Dr. Mika Matsuzaki from Johns Hopkins had the idea for creating this food composition wikibase. And the point of doing this was to support her research in nutritional epidemiology. And we also have on the team Kenneth Sealsnut, who is our software engineer. And then I work on most of the data and the mappings with Wikidata and FoodOn. Our motivating question is, will the combination of data sourced from global food composition tables reduce data disparities for people who record nutrient intake? So we're working from published food composition tables, but many of these are only available in analog formats. And so we are making these available digitally and also enabling multilingual searching of these resources and mapping them to ontologies like FoodOn and knowledge bases like Wikidata. So many of you are probably familiar with the different language versions of Wikipedia, but Wikipedia is just one of the many projects of the Wikimedia Foundation. And the project that I'll be talking about in relation to WikiFCD is Wikidata. So Wikidata is a knowledge base of structured data, and it is systematically interlinked to all of the different language versions of Wikipedia. And just like you're familiar with all of the Wikipedias, anybody can edit Wikidata either with an account or through anonymous IP. And Wikidata is multilingual in more than 300 human languages. And it's been around for about 15 years. And there's an active core of several thousand editors that make at least 50 contributions each month. Wikibase is also a word that you'll hear from me from time to time, and Wikibase is the software that enables Wikidata, but just like all of the software created by the Wikimedia Foundation, Wikibase is open source and anybody can reuse Wikibase for their own purposes. So you can make a knowledge base using the same enabling technology as Wikidata for your own data. And so Wikibase is the name for that enabling software. So the goal of our project is to create a free, open, dynamic, and collaborative global food composition database using a peer production model. And by peer production here, we just mean that anybody is allowed to participate in this and can actively contribute as well as reuse the data. We have started with the list of food composition tables, most of them at a national level, that is available on the FAO website. And so we have data in there from the Smiling Vietnam project, Smiling Indonesia, Laos, Thailand, some from Japan, and also from Malawi. And we also have the food composition table for, or the food composition values for many of the foods in the USDA Food Data Central. So I'll close there. I'm happy to demo WikiFCD at any point during the week and show the mappings to FoodOn and show the mappings to Wikidata and answer any questions. Thank you.
We have time.
Yeah, we've got a lot of time for questions.
No, for questions, not to do the showing.
Oh, I see the demo, right? I actually can't remember. It's the last one this morning, right? First presentation. So can you do it in like 10 minutes or?
Okay to allow that?
Mm-hmm.
Oh, it's the old link, sorry. I think that we migrated the database since I put that link in there, sorry. I think that it might be more complicated than
Yeah. So where are your pain points in this project? You would confront many of the similar challenges that PTFI is probably getting. People are not describing their samples in many ways.
Yeah, so the food composition tables from different countries, there's a big time range for when these were published, and they do not all use the same structure for their data. So that is the first pain point. The second pain point would be not all of the food composition tables include the scientific name of the food. So sometimes we only have a local name. Not all of the food composition tables provide local language names for the foods as well as English names. Some of them are just in English, or some of them are just in other languages. And then all of the mapping to FoodOn is all done manually. So that's another pain point. We also have varieties that are not in FoodOn sometimes. And all of the mapping to Wikidata, we also do manually.
Like there's a lot of manual stuff going on here and there.
Well, I mean, if you want well curated data, you kind of have to make sure it's right? But there should be standards for how we do things, and we'll talk about this in my section, but I'm really interested in having this conversation with you later, but I'll hold it for now.
But I hope that in time we will get more and more foods, and then it will be easier if we receive like an older food, and we have a species with that food, so we will just map what we already have.
Yeah, of course, but we need standards that work together. That's the point.
Because it will be interesting to know how we are doing the mapping, even if manually, because we know you rely on some criteria. Yes. So it will be the basis for the common puts all together the criteria, and then I think that
Yeah, we have a section for mapping that we'll talk about in this workshop, and we're doing a second for my which is about
yes,
standards.
it will be on Friday.
So far, but we can make it remind us. Yeah, you did, it presented a multilingual interface with the FCD last summer.
Yeah, and all of our multilingual data, so if we don't source it directly from the published food composition table, then we do it through the Wikidata mappings, and then we use the labels that are available in Wikidata. So if we have it directly from the published food composition table, then there's a different level of trust with that data than if we are just using labels from Wikidata in different languages. We can't be as sure that that food label in that language is what somebody would have selected at the time if they were making that decision. So, but yes, we do have the ability to bring in a lot of multilingual data from Wikidata, but it's a little bit less trustworthy than a name that was assigned at the time the data was originally created.
That's without be a challenge with FoodOn in both the synonymy and the mapping tracks to determine to what extent a source is trustworthy, and therefore we can offload all of our curation onto that source, or whether machine language translation, some ChatGPT variety, is trustworthy or not, because I don't want to get in trouble, no one does, in FoodOn with referencing people, things that really don't exist, or totally wrong about the foods. That would be especially dicey in the mushroom section, say, where some of them were toxic, and so there's actual risk involved.
Discussions of provenance and misinformation, like who contribute what to where did you pull that from? How do you trust that whatever?
So I guess what I'm looking for this week from you is a discussion of, for example, the varietals and the cultivars that are in Wikidata, whether those are trustworthy names, for example, such that we could offload our referencing instead of cooking up FoodOn references to actually start using those as an example of this.
Because I think that different dimension, you have the mapping based on the labels, and then you have to add some information to have more trust, rather than just the labels, just the strings, characters. You have to include other criteria.
Exactly.
You're speaking of varietals
or mapping.
For example, for mapping, especially for varietals, I think, or for mapping between local names and scientific names, for example, because are you sure that all the local names are synonyms? And you are referring to a taxa, because you have to attach the varieties to taxonomic level. So you have to, you must be sure that you are going to speak about the same things.
in Wikidata, the beautiful thing is that the labels are stored per item. So you would have a different item for the taxon and then for the varietal. And so the labels would be stored directly on the item for the varietal. Now, of course, and sometimes for a language like Spanish, we already heard an example of how different countries have different names for different varietals, even though there would only be one slot in Wikidata for a Spanish label. So there is another way that you can also store more specific language information on varietal names. So Wikidata can accommodate that data, but then we have two different patterns that we would need to query across in order to make sure that we're getting the most complete information from Wikidata.
Yeah, so the mappings and the varietals tasks are both going to be very relevant to this.
Yeah.
We're going to hear a lot more about it then.
Mental note, add 1 more hour to mappings.
Yeah, excellent.
Thanks, Kate.
Yeah, thank you. That was amazing. Thank you so much for bringing your expertise. And we're looking forward to it.
Any other questions for Kate? Well, I mean, we get to talk to her all week, so that's great. All right, then let's have a 10-minute break. I'm gonna go see what that tray is over there. It might actually have coffee on it. So.
Okay, so I'm going to talk a short bit about the Dutch National Institute for Public Health in the Environment and what we do or do not do with ontologies, or we want to do with ontologies. And that's basically because we have a lot of data on food and everything that's got something to do with food. And I don't expect you to read the left part because it's small and it's in Dutch. But basically, it lists just the databases that we have. I want to focus today on 4 of those. And that's data that we have on branded foods. We've got label data of branded foods. We call that LEDA, just so that you know, I'll get back to that. We have generic foods, so the nutritional composition. And we've got food safety data, contaminants of foods of raw agricultural commodities. And we recently also obtained environmental impact data of food consumption, also for generic foods. And we would like to combine that data, to link that data together. And that's why we were interested in ontologies. Because in all of those data sets, we describe foods in a different way. And I'll show you an example. And also because we think that if we manage to use ontologies to link those 4 data sets, we will also manage to link to other data sets, for instance, sales data or from different domains like food production, et cetera, et cetera. So this is a picture of what we try to do with those 4 data sets. So over here you see that we would have a wholemeal wheat bread. And in our generic food composition database, the products would be described in a very systematic way, but not very related to common language, so to speak. So you're not going to find a wheat bread wholemeal fine in the supermarket. You're going to find a baguette boulogne in the supermarket. And the trick is, of course, to know that those two are connected. Whereas in our contaminants database, you won't find bread at all, you'll just find wheat. And in the LCA data, so the environmental impact data, it will be described in a different way again, as bread, wholemeal, processed in the Netherlands, wrapped in plastic, and it's no preparation, no domestic preparation. And so now we've come to the point that we can sort of link them together using some pre-processing steps in purple field there, and to link them to FoodOn and then to link them together. But this is still difficult. And why is it difficult? Well, because there are inconsistencies on both ends, right? So foods are not always described with the same level of consistency or the same level of detail in our own data and in FoodOn. And here's an example for some nuts. We wouldn't have data on whether the nuts are dehusked or not, where you would find that data in FoodOn. But in FoodOn also, even though it looks quite complete, that you could still ask, okay, so is the pecan nut, is it dehusked or not? So there's always these difficulties of making the matches. And this is also a difficulty, but I'll leave that for Felix to explain because he's more into the technical stuff.
So with our knowledge graph, we aim to combine also the branded food products and map the ingredients toward FoodOn to get this higher view, and also be able to map the primary agricultural products to the ingredients that are being used in these kind of products, to also get an estimation of the risks of certain contaminants they could contain. And this is difficult because of several reasons, because whether a contaminant is present is also dependent on the processing of the ingredient itself, and this is not represented in ingredients themselves often. And which is also difficult is that sometimes in FoodOn not the industrial ingredients are mentioned. An example here is the hydrated plant-based protein, which is fairly important for the research I'm performing. But only FoodOn class that would be available would something like FoodOn or plant-based protein. Well, we actually want to get to that higher level to the primary agricultural products. So for this one, it would be hydrated soy protein and hydrated wheat protein, which we would want to annotate. And that makes things a little bit difficult. And also, as everyone else, we have the difficulty of actually annotating all the data to FoodOn itself manually, because it takes a lot of time. And for now, I tried to solve that using text embeddings and a small program to select the label itself that suits the label I'm looking for best. So for in this example, it would be spinach frozen boiled. But then again, to the first problem we had with Ido as well, which one of the labels would you annotate it to? And for now, I only use the food product branch in the FoodOn ontology. So yeah, that's also one of our problems, which I hope to fix at some point, because especially if you are looking for the ingredients that are being used in branded food products, it's going to be very difficult to do that manually all the time. And then a short slide of tools I'm using, because that was a request. So I'm mainly using Python and RDF-lib to create my knowledge graph and annotate the data, but I'm also intending to use YAML, which is a RDF modeling language, which makes it easier to get from a class to an RDF graph in the end. And to query everything, I'm using Gina and GraphDB at the moment, but they are not very user-friendly. So I'm hoping you have some suggestions for other graph databases to make sparkling, to make Sparkle queries easier, and also integrate it into a Python script as well. So our key learnings for now is that you need to be pragmatic for your annotations. So for now, I annotated everything towards the food product, so the chickpea food product or the wheat food product, if there was no suiting class available. And that actually the labels or the ingredients that are being used in these branded food products have such a generality that most of them can be actually annotated to FoodOn, and only not the specific ones and the specific industrial ingredients. And to find links between the different data sets, now I'm using the ontological distance between two classes, because you can imagine that with the different levels of generality, you will not find the same IRI for a specific food item, while there's still information related to that FoodOn class somewhere in the ontology. And for the lower classes, this works fairly well to find similar items across the data sets. But once you go higher into the hierarchy, then you get to do weird connections. So yeah, that was my main keys and my takeaway for the research I'm currently performing.
Questions?
Yeah.
Correctly, that you were looking for a tool that would help you use Sparkle in Python, or?
Yeah.
Actually, I think OWL ready to help soon.
I'm also now using already too, but it's I'm using already to sparkle the ontology, but not really the graph. So I've not tried it yet. But
Apache Gen is good, but you want the documentation. It's difficult. But we can talk it offline.
No. Thanks. Yeah.
I'm working with the real food product labels, and then you are passing the label facts, the nutrition facts, to extract the ingredient list.
For now, I have this data set with the food composition data, and I'm using the main labels to annotate the food on, and then I map it back to the nutritional values as well. And the nutritional values are again mapped to CDNO as a descriptor in the schema.
Show an example. It's just like an ingredient list from your real product, and then you have extract the names of the ingredients.
Yeah.
Next slide.
Yeah, here. No, here. Your ingredient list.
This is actually a label from
I think Mark actually was about this one, right?
Oh, sorry.
Extract the terms, basically the terms, the names of the ingredients from the nutrition fact of the product ingredient list, and then we're trying to find them out in the hierarchy. That's it. And so for doing so, you are next slide. you are using this kind of words embedding to find out in which label or which classes you can match. That's it.
Yep.
And your Dragon, is that Dragon AI or Dragon?
Yeah, it should be. It was. I'm using the same method as they use in Dragon AI to get the embeddings.
So that's a typo.
That's a typo. Yeah.
Okay.
Yeah.
Like you're connecting wheat to wheat bread. But you're explaining already what you find in wheat. Necessarily find it back in the bread. But I understand. But how do you deal with that? I mean, you connect them. You make some kind of decision.
Decision on what?
Well, some indication maybe, like what you find in wheat, you may not necessarily find it back in the bread because it's processed. Or do you have the assumption that everything you find in wheat, you will find it in bread? Maybe that's my question.
Well, that's actually that's what our colleagues from the food safety department are modeling. So the relation between contaminants found on wheat and contaminants found in bread. So that's part of
one-on-one.
Well, I don't think it's an exactly one-on-one relation, but it's not our expertise to make that model, but our colleagues do that. Yeah.
First slides where you seem to combine wheat with bread.
Well, at least we want to know what are the contaminants we find in wheat and what products are wheat, and what in which products is wheat being used. So which products do we need to be focused on if we look for contaminants?
So
in the graph we're using, the data sets are still in their own schema, only connected through FoodOn. So it still asks for the impact or the contaminant of this specific FoodOn class.
Yeah, thanks. It's that slide in that, when we looked at creating FoodOn, there was a siren database of over 7,000 food products that was coded in like wow. And we thought, oh, well, that would be a good way to bring all of those products in. And they had their own hierarchy. It was according to the US Code of Federal Regulations, some kind of product hierarchy they had. So that was, and then between that and Langual explains why these things are here. But almost all of these were from the Langual siren coded database. Only spinach bunch and spinach head leaf. Only these are actually sort of a function of our new templated system, because these are the actual anatomical parts without any assumptions about whether they've been cooked or anything has been done to them. All of these are legacy items from the siren database. And the design question is, should we indicate that more strongly, that they're from this product database, but that we actually have some rules now about which products will pre-compose a term for and which we won't. Like, maybe we won't have a pre-composed term for spinach frozen boiled. That will be up to people to have a spinach and then the frozen spinach and then boiled as a separate bag of terms descriptor. So this is back to the question of what terms are pre-composed.
Well, what I wonder is this spinach frozen instead of the leaf? Or the head or the bun?
Okay, good. Yes, touche. Right, and so it would be incumbent on our definitions to say so. And siren didn't do very good because it didn't have any definitions for any of its products. You could only tease out through Langual, whatever anybody coded in Langual was what is given in FoodOn in that extra comments field. And only there might you find that it was spinach leaf.
And this is with the process facets from Langual more specific.
Yeah.
Including for the process.
There are processes there, whether the curators from Siren actually use them or not. This
It was a heterogeneous way of using this facet scope.
right. They did have a menu, right? Conceivably, they could have. Whether they did or not in the Siren database.
But actually, for me, the match will be like spinach cooked. It's like because it's boiled, the probably will be like better.
For the food composition, yeah, right. That's the last state that it was a tested state. But what they're wanting is that somewhere it's captured that it was previously frozen. And in fact, if spinach is frozen, I think it has to be blanched anyway. So it's actually pre-cooked.
Basically,
Frozen.
do you remember the specimen sample categories that we had? So for example, it could be that specimen is frozen and the sample frozen and cooked.
Yeah.
But just my question here is more actually because right now we have like a mix or like heterogeneity in FoodOn, because in some cases we have this kind of cooked spinach, in some other cases not, because well, we are thinking about this post-compose. So my question is, at some point you will change these terms, edit it, like to remove it, or you will maintain it? Because it's kind of weird to have like this heterogeneity in the different levels of specificity.
We'll be talking about this in the template section. And the idea that we propose is that the menus provided for tagging something would include cooked and frozen.
But you will remove these terms from language?
We don't have to remove these ones. No, I mean, these are perfectly valid terms to have as pre-composed terms in FoodOn. So we have to just have a policy about when we invite people to add more pre-composed terms in a custom basis, like on this food or that food. in whether, when we actually mint terms with pre-composed terms according to a pattern across all of the foods. So this conversion to the animal template is having us mint terms all the way across the board in a number of ways, but we still haven't done that for frozen or cooked. We did it for dry and raw.
We can imagine very generic templates because we have to think about the different way we can combine things. For example, we can have some raw product then frozen then cooked, or you can have some raw product then cooked and frozen.
Yes.
So you can imagine what is the combination.
Exactly. So this.
Or at least the most probable thing.
We'll get into it with the templates thing, but yes. While we may hang on to spinach cooked, say that entry doesn't mention anything about whether it was previously frozen and if previously frozen blanched. There's all these hidden processes that are involved, and we only know spinach cooked. We don't know those other possibilities, and therefore we have minted a term that has ambiguity in it, and therefore should only be used in certain cases where people have ambiguity. They don't know whether it was previously frozen or not when they came around to test it, for example. So it's this information level in the pre-composed term that may be hiding ambiguity.
Because either you know the history or not. So when you are knowing the history, you need to be precise. When you do not know the history, you will still remain vague, but you have to because otherwise you will be nothing.
That's where it would be nice to have a process model engine. Sorry. That would spit out the sentences that we need to adequately describe your sample. Even if I discovered only 2 or 3 of those pre-composed terms.
See spinach frozen there. Sorry. Would you like to define like a subclass for spinach frozen, like spinach frozen with first? Sorry, different about something. Got spinach cooked, then define a subclass like spinach cooked, but it was frozen in the past. Yeah, okay, okay.
Yeah,
I think that would be good.
FoodOn is moving to adding, trying to indicate where possible the order of the processes involved that were known in that. So spinach was chopped first, then frozen. So this actual order isn't trying to get at the process.
Initially, I thought maybe like simply defining more spinaches, but then you cannot generalize like spinach that was cooked and before frozen.
You could, the combinations just become insane.
Yeah, that's my next question. No, my next fear.
Yes, so that's back to what does the ontology precompose and what does the ontology allow for a language that allows you to write your knowledge graph statements about your sample. It spells that out, but you don't try to precompose it.
Because FoodOn's in a difficult position where it's trying to service a lot of different stakeholders who want things that are slightly different but overlapping from each other. So how much FoodOn has to do kind of depends on what people ask of it. But I think it's important for FoodOn moving forward to define these policies of like, we draw the line here.
It's one thing, and then this week, yet another strategy is to provide a view on FoodOn that only gets you the hierarchy of terms that you want. Say a view for the hierarchy for people who aren't involved in sample testing, they're involved in creating a storefront for the town.
Well, clear demarcation is right.
It would be helpful, yeah.
Also to make it to be.
Okay, we have.
All right.
Thank you very much.
Welcome.
It's great to see you. Okay, so I think Kai, you're up next. Hmm. Yeah. Let's
Share and full screen.
and
Let's see.
slideshow,
Yeah, on a PC. All right, fantastic. Y'all can see. All right, my name is Kai Blumberg. I hold a PhD from the University of Arizona and a master's from the University of Bremen. In my day job, I am employed as an ORISE fellow associated with the US Department of Agriculture, but to be very clear, I am not in any way representing either of those organizations in this talk, and I'm simply here on my own as an independent scientist who happens to be on holiday. That was all the official record. So I will not be speaking for USDA. I'm simply speaking about research that has been presented before public forums like the NMDC conference in Ottawa, and it's a recap of that knowledge. So for those of you who are familiar or perhaps not, the United States Department of Agriculture has a centralized website called Food Data Central, which is essentially a hub for all of the food composition data that the Northeast area is producing. There's a lot of departments at USDA, they do a lot of different things, but a lot of them have converged into a single place where you can find this publicly accessible data. The institution is mandated to provide the data publicly, and many people around the world make use of these data, probably some people in this room. So just at a very high level, they at FDC have 5 different database types or data types. I will just very briefly go into this. That's not really what this talk is about, but just at a very high level, so people are aware. Some data sets that you might be familiar with, for example, the SR legacy data. I think that was mentioned in someone else's talk. I think in the wiki, I think you mentioned that in, I believe, in your wiki talk.
Damien said SR legacy, but
Yeah. So anyway, so the wiki, it'd be an interesting conversation to see which of these data sets wiki is using. I assume it's probably this one and hopefully this one.
we definitely have both of those.
Perfect. Fantastic.
But we have everything that was available in the API, so we didn't do it by.
Okay, interesting. We should have this conversation. Anyway, so the long and short is that basically there are 5 different, these different data types. These 2 are both original analytical food composition databases. That means like someone took an orange, they measured the vitamin C of like that orange or a composite of oranges. In this one, it would be a composite of oranges, the legacy data. So they kind of might have forgot to press save on the individual values, and so they just gave us one orange vitamin C concentration. Here, the policy was changed and pressing save on the individuals was a thing that was done. And here you would have, 13 different oranges, and each of them you see their vitamin C concentration, for example. This one is newer. It only started in 2018 or 19. I don't remember, but it's much newer. There's only about 300 foods on this one. This one is older. It existed since the 70s, and it has thousands. It has like 8,000 or 7,000 something foods. There's a lot there. This one's for survey data, so I won't touch on this. This one is just experimental data that's kind of similar to the others, and this is labeled data, similar like to LIDA at RIVM. And so basically what I'm going to talk about today is in another life of mine, when I happened to be a USDA postdoc, there's this project which I'll be speaking about, which is basically like, how do we use these data sets, like possibly all of them, but at least these 2, maybe this one, together in a unified way? And also, how do we bridge that with groups like PTFI or RIVM? Like, how can all of us who are doing very similar things work together in a machined way? And so basically from a USDA perspective, they moved away from the composite analysis of samples to individual samples, because they realized that, there's a lot of things that you need to be captured within food composition data, right? There's like chemical factors, genetic factors, environmental factors, agricultural practices, lots and lots of things that might cause variation, geographic variation, much variation in foods. So the new sampling approach better accounts for that. And of course, with this project that I'll be speaking about, we're really addressing like, how do we deal with data siloing? Like RIVM has their data over there. PTFI has their data there, USDA has our data or their data in two different places. How could all those institutions or within an institution connect that data when it's relevant? Yeah, so there's just a lot of information that needs to be captured to make a good food composition database. So one of the ways in which a lot of different life sciences have helped to make their data interoperable is through the use of minimum information standards. Minimum information standards, very simply put, are sets of guidelines and formats for reporting specific scientific data. So whether it be, genomic features, whether it be plant phenotypes, there are many, many of these types of standards that exist. And their purpose, the goal with them, is to enable you to structure your data in a consistent way, analyze and interpret it, and also allow data sharing or data mining across different, users, allowing people to pool their data, their multiple data sets together to do new analysis or to redo analysis, etc. So, as I mentioned, within the life sciences and a few informatic disciplines, there have been many, many different minimum information standards that have been created. I'm just highlighting two here, but there are literally hundreds, or at least dozens. I don't know about hundreds, but there are literally dozens of these things. The plant phenomics standard, the genomics standard. Some people here might be familiar with that. That one touches on the environment ontology, which Damien mentioned earlier. But the point is that there are structured ways that people can report their data in order to help make the analysis of that data interoperable across data producers and providers. So the goal of the work that other Kai, who is not here, who is a postdoc, is doing is to create a minimum information standard for food composition data. So really, really basic idea. Minimum information standards have been really successful in a lot of disciplines. But as we all know, lots of different groups around the world are doing their food composition tables in different ways. And so from my perspective, just speaking for me personally, it would be great if there was an open source community-driven standard that everyone could agree upon and contribute to, or at least map their other existing standard to. And we could all kind of be on the same page about how we annotate the data and metadata relevant to a food composition table. So that's what the MyFC project is about. Minimum information about any food composition data standard, kind of modeled after the other genomic standard, which also makes use of OBO ontologies. And so really this section is about, kind of data standards, how we harmonize those data standards, and how those data standards can make use of existing tools like FoodOn, existing tools like Langwell, EFSA, all of these different institutions, USDA vocabularies, mappings between USDA vocabularies to other institutions like other vocabularies like FoodOn, mappings between FoodOn and other institutions like RIVM or EFSA's data, et cetera. So it's really kind of like a framework that this could be done. We can put these things together, at least in the field of food composition data. So what is it that people would want from a food composition data standard? Well, obviously it needs to be standardized. First and foremost, you want to make a standardized representation of things, and it needs to be comprehensively annotated in terms of attempting to capture as much relevant metadata as possible, relevant to a food composition table, where it was created, where it was collected, where it was distributed, how many times was the spinach frozen before you boiled it. There's a lot of data there's a lot of metadata there. It needs to be a transparent standard. People need to be able to understand it. And it also needs to, in theory, it should also be able to do things with kind of future-facing technologies, like allow people to convert between formats, things like even just simple things like between CSV and JSON type data or other data formats like that. The goal also is to help the interchange of data between stakeholders. So if, like USDA, if ever in the future they wanted to take data from RIVM, right? Like they wanted to take the NEVO database and include it either in USDA, or if someone else wanted to take RIVM's data and USDA's data and be able to actually use them together more easily, we need something along these lines to make that actually possible. And in order for this to be something that could actually be successful, it needs to be something that can adapt to users' needs so that it actually can be adopted and not just forgotten about in another trash ban in the history of standards. And to that point, it needs to harmonize existing standards, make use of things that already exist, and try to tie them together for this specific purpose. Yeah, so just in general about the development of the standard, kind of asking questions at high levels like what data are minimally required to be in a food composition database. Really help, and this is something that the FoodOn community can help with, providing definitions for what is meant by foods and components of nutritional interest. Even that right there could probably be a whole workshop, just kind of discussing that. And to use vocabularies like FoodOn, or the possibility of mappings between FoodOn and Langual or EFSA2, et cetera, to be able to actually bring those data together and use them within a new standard like this. The standard should also really do things like clarify approaches for data reporting, right? It should really be clear. It should mention, you know, what compound was being measured, what units was it being measured in, what protocol, is it analytical data, is it omic data, et cetera, et cetera. There's just so many details that are really relevant to a food composition table that just absolutely have to be pinned down and standardized so that the whole thing is transparent, that you know exactly what this data is describing, and you know if you want to compare it to this other data or not. And finally, of course, to do this, there need to be, you know, a lot of different metadata attributes that get attributed. Things like, you know, what country did it come from? What was the varietal? All of these things, like we'll be talking about some of these things in the workshop. So just as a kind of very brief demo, this might be a little hard to see, but basically this is an example of the standard in action using USDA data with the USDA component vocabulary. So you can kind of see here the standard. It's a big table, but basically what it's doing is it's enumerating what compound was being measured. It's enumerating, you know, what the amount was, what the units were, and also some of the methods. And a kind of a way of looking at this is that MyFC could help maybe bridge for the food composition world's existing gaps between systems. So for example, the components table could come from a lot of different places, right? Different institutions and groups are doing things like this. So USDA has its own components vocabulary. Eurofer, the European Food Informatics Resource, they have their own components thesaurus. CDNO, as was mentioned here, that's the Obo Foundries component thesaurus. KEBI is also, CDNO is built off of KEBI. There are lots of different possibilities for what could be used to annotate a component within a food composition table. And this standard is really trying to like say, okay, this place within the data model, here is where you would use a vocabulary term to annotate your component comprehensively. Similarly with other things like methods, right? There's lots of different standards, right? There's AOAC in the US, there's the CEN in Europe, there's UN FAO standards. All of these things exist, and there needs to be ways of bridging these things. In food component tags are a combination of these two things. So, you know, to be able to leverage in-food systems and connect with it, one would need to compare, to map the in-foods tag to both the component and the measurement that it was used to generate it. So there's a lot of challenges in trying to make something that would work for lots of different institutions and standards like this. Yeah, lots of different things about EFSA. We can go on forever about all these things, and we'll have a session about this. So basically, the future directions with MyFC is that at the moment, the goal is that it will be underlying the data in the upcoming April release at USDA. That's not 100% certain yet, but that's just kind of like the plan that, you know, certain people have that they're working on behind the scenes. And then more broadly, beyond USDA, really the goal of this idea is to, you know, create a standardized format to be able to serve various stakeholder needs, right? Nutritionists, food composition database compilers, lots of different people use food composition data or similar data for lots of different purposes. And we really want to help to enable data exchange using the standard and maybe make life easier for certain people like food database compilers. So this is still very tentative and in the works. There have been a lot of discussion about trying to do this. I don't have any solid answers for when this will be facilitated by USDA. Perhaps this will only come later in the future after USDA releases the initial version of this standard and then makes it open. Those are open questions which I cannot speak to because I'm just a private individual who just happens to be standing in front of you. But there is movement, at least in terms of a publication that will be submitted soon or is being submitted at this moment, that there is impetus to move in that direction at the agency level. But again, I can't speak to that. That's just me hypothesizing about what might happen. But the goal is really to, like, if that was allowed, or if we get just generalized feedback from, you know, people like you, we can really help to solicit your expertise, and you can tell us what maybe is missing from the standard that helps to bridge to other existing standards. With the goal really being, like, you know, we recognize that food composition data is universal, and, you know, people all over the world do this, and we want to make the situation better, not worse, and kind of help to bridge those gaps between different institutions and countries. Yeah, so in summary, the minimum information standards help to enable data sharing. There's talk of a project about the minimum information standard for food composition data, which I refer to as MyFC, that is in the works. And the objective is really to make food composition data findable, accessible, interoperable, and reusable so that different people can use it. And of course, that's really challenging. Hopefully, eventually there will be opened up to an international working group, or even just become a independent standard that's managed its own ways. And once available, there is hope that this will become something that people could participate in. Yeah, so that's the core of the MyFC slides. I just want to really quick touch on this because I think this is relevant to our discussion here, which is that we're talking about ontologies a lot in this group, right? We're formal informatic representation of knowledge, which includes, you know, all sorts of things, hierarchical structures, relationships between concepts. There's a lot going on there, but you don't always need an ontology to deal with your data for your application. Sometimes a controlled vocabulary like Langwell or a data model is sufficient for your purposes, and it depends what the purpose is. So in the context of this group, FoodOn ontology is doing a lot of work to try and model so many different things. But with the MyFC project, it's more at the level of a data model, which gives a structure to a database. One second, sorry. A structure to a database which can make use of certain ontologies or other controlled vocabularies for a specific purpose. Yeah, please, did you want to say something?
Very happy with all your discourse, and it's very clear, and you're very good at explaining things, I think. But I don't really agree with your hierarchy about theory, just to say that it is just a matter of whether you are looking at the definition for human or not, because in the theory, normally you have a good way to link SCOS definition, which are more appropriate for different languages, and then you have the taxonomy sides of point of view, and so you can link.
Yeah, fair enough. Fair enough. This is just a generalized way of saying that.
It is good what you say.
All the slides, it's not trying to say one's better than the other. It's just saying that, like, if you define a thesaurus as like synonyms,
yes,
then it's here. If you define what you're talking about as a joint
yes,
taxonomy and thesaurus.
There's a different
You
function.
may find more data if you go.
Yes, of course. Yes, it's just a matter of what you want if you want to for the synonym.
Yeah, no, of course. I'm not trying to make any more statements than that, other than some people view it this way. You can totally disagree. That's totally fair. You could have something that's like a thesaurus and the data model together. Yeah. So yeah, it totally depends. There's, like I said, lots of different people doing different things, possibly sharing things. So MyFC is basically an attempt to make a data model that uses ontologies like FoodOn or vocabularies like FSys FoodX2 to model data for a specific application, food composition databases. And that's why it's really relevant to this workshop, because FoodOn is one of the main vocabularies that USDA has been mapping to to try and bridge itself out to the world.
Yes, and maybe when you speak about control vocabulary, in fact, you are more thinking about a coding system or reference for a label.
That would be an example of a controlled vocabulary. Yeah, so anyway, so I think that's pretty much the talk. If maybe Damien, if you don't mind, I just quickly do this slide. Just for people, so the word ontology is going to get thrown out a lot this week. So just so it's really clear to everyone, here's my understanding of it, and others feel free to chime in, although let's not do too long on this. I want to focus on my FC or get kicked off the stage soon. But basically an ontology is like a way of representing things in the real world, concepts, in a machine and human readable way. So, you know, like what exists in the world. It originally comes from philosophy, and in the 20th century and 21st century, we bring it into the computer. So you have a concept like a fruit. And then maybe you could have a sub-concept like a plum fruit. These are all examples taken from FoodOn. And then maybe you could have different types or sub-concepts of that sub-concept. So you could have apples, which are a specific type of plum fruit, or pears are a different type of plum fruit, etc. And maybe you could have other types of relationships within an ontology. So you could say that an apple is derived from a taxonomy, a taxon like Malus domestica. So if you told a computer, like, I have this plum fruit and it came from a Malus domestica, the ontology or computer system would tell you, okay, you have an apple.
Like we use different terms like sub-concept.
Yeah, this is just a really high level way of explaining it to a general audience. Yeah. And then usually ontologies in the 21st century have IRIs, which is something, a term that's been thrown around a lot. Damien's been talking about mint identifiers. He literally means like make a web link that anyone can access to put in their database. So like you're annotating your database with Apple, they're annotating their database with Apple. Both of them can be made interoperable by literally using this same link or the shortened version of that link. Just so we're clear on terminology, so everyone's on the same page.
Also guarantee that the concept is unique.
Yeah, exactly. So this is like a unique place on the web that specifically says this thing is an apple, which is whatever the graph says it is, and the definition
actually used to define unique things.
So that's just really high level about ontologies. I can probably go off the stage unless anyone has questions.
Yeah, one time question maybe. You were talking about combining Liaison with USDA data, for example. How would you deal with regional differences of food composition in products?
Yeah, no, for sure. There's a lot, and I have examples not on this slide deck, but it's difficult. But basically, the long and short is that it's a really long data structure, or not long. It's a simple data structure. There's a food and component table, and there are tons and tons of attributes, like these literally columns that can deal with it. And again, I don't want to take 2 hours to explain the whole thing, but basically, there's a lot of different attributes that help to deal with different things. So one of them deals with, whether the name of the varietal, one of them deals with where the country, it just goes on forever, the list of things, and we can talk about it more in the group. Yeah. Any other questions? Or I'm really hoping that we have like so many people in the room here who like are probably interested in something like this. Maybe the wiki people or like the RIVM people, the people who work. I mean, I don't know, you don't work for EFSA, but like, related to.
I'm not working for EFSA, just as you are not working for USDA.
Right. So we have to, yeah, we should agree that we're not doing anything. Yeah.
Any question, maybe the same about if the nutritional content of a product would change over time.
Yeah. So that's a really good. Yeah. So like literally, now USDA has literally gotten, again, this is me not speaking on the record about this, but like the USDA has literally gotten mail from people in the past who've published articles saying like, hey, back in the like 1975 version, spinach had this much vitamin C. And I look at the table today in like 97 and it went down. Right. So like a way, in my opinion, again, this is just my opinion. Agencies like USDA or RIVM should make their historical data also available, rather than just having one, okay, this is what spinach is now. It's like, okay, that's great for people now, but like, what about digitizing the 1975 version of the book? And then scientists can compare, oh, that is interesting. Spinach did lose vitamin C since
data, and that you've got data from 1975.
Yeah, right. There's lots. So I am totally a proponent of that. But I think at the moment that the challenge for USDA is to like just put its own data sets together. But I think the next step would be to use historic data as well.
As far as the context of this information, can be used.
Right. Older data is nice historic value, but maybe you don't know the context. So there's challenges there too.
Yeah, the challenge is to get all your metadata for the historic data. When you're talking about different processing or different, analytical values.
Because you don't know them.
We don't know what happened in the past.
Right. Yeah. Yeah.
Documentation.
But
Yeah.
the interesting is that you cannot have everything, but you can have something. So for example, if you have like 3 metadata element count for 50 years, so you can make some studies or analysis using that.
Yeah.
Yeah.
Yeah. So
Further back you go, the more holes there will be.
I think the most important is to use the information that we have in the same way. Like even if we don't have exactly the same.
that's the point of this. So that's the point of making a standard like this, is to say, okay, USDA has their standards, UNFAO has their standards, RAVM is doing kind of, they have things they're doing, PTFI has things they're doing. Is there a way that we can converge on something that looks like a universal standard that USDA is already writing to?
I just have a question, and it's that we have a lot of standards. So how we can be sure that this is not another standard? Do you know what I mean?
Yeah, it's like that XKCD comic about like, let's make another standard. Yeah. No, I hear you. That's a good question.
Standards. So it's also the same for PTFI, right? Like we have right now a standard, but.
So that's why if scientists or like private individual Kai, if he was more in control of things, what he would advocate for is a community bottoms up open source standard that anyone can contribute to or participate in.
Yeah,
and that would help solve that problem. It's not going to solve everything, but that would help go a long way, rather than USDA says it has to be this way, FAO says it has to be this way, and they never meet in the middle.
Also, just thinking that it would be great to have participation in these communities.
Yes.
Now, at the end.
I agree. Private individual Kai is 100% on board with that, but.
So I think we can regard MIFC as the first iteration, and it's inspired entirely by the USDA's database content so far.
And PTFI's standard.
And PTFI, okay, so that's a start. I'll just make one meta note before we break the lunch, which is a lot of these standards, people start fighting about like what the labels are, what the definitions are, and then they don't. So to make something a standard is actually to pay attention to a few things. And this begins to sound a lot like ontology work. So you, first of all, you don't care what something's called so much. It might be called something in one system, something in another, but you have an identifier that uniquely points that thing out. So suddenly.
And then that's the next step.
That's right.
Make
That's
that
another
mapping, yeah.
step. And then the third step is say, oh, well, we actually need something a little more convenient for the programmers to use, because they may not understand the ontology term and whatever the label is, the language labels varying all over the place. So I is actually put what I would call the coding name for the column there, in a particular format. So that's, we're offering people at least 4 different things when we're offering a standardized item. The ID, a label, of which there may be many, a coding name, and a base English definition, or other language definition. That's all. That's you almost made it to the standards walk of fame if you get there. So, and that's lines up nicely with ontology work.
Exactly. Where in specific fields, like you don't necessarily, because ontologies take a lot of work to build. You can't make an ontology for everything. We don't have enough time in our lives to do that. We'd all have to dedicate a lot, but you could use a controlled vocabulary for something and an ontology for another. So in instances like things like the component type, there's already like at least 3 or 4 existing ontologies of vocabularies. And so a standard would be mature and say, like, I don't care which of these you use, please use a standard, or if not, add a 5th one or a 6th one, and we'll accept that too.
And behind this is, we're going to be propagandists for this platform called LinkML, which allows you to do everything we just talked about in terms of.
Yeah, so there's the whole tooling ecosystem that Lawrence Berkeley National Labs is developing, which the prototype of this is in.
Possible addition, if I may, we agree. On the one thing, to my opinion, an idea should also be readable. So that the usability will be improved.
Yes.
Well, this is where it differs. We can talk about it over lunch. But,
this is also a whole workshop to discuss.
I agree with you.
We did that in the past.
I agree with you. I agree with you.
I just wanted to mention.
Yeah. Okay, any other things on this, or should we wrap it?
Yes.
Okay, I'm gonna go ahead and wrap this then.
Yes, thanks, Kai.
Yeah.
Right, so the MIFC task is going to be likely to see what work needs to be done to map MIFC categories to FoodOn terms.
Or
and
other
others.
people's vocabulary, or other needs that other institutions have, that FoodOn could be enriched for some of, maybe not all, but some of for sure.
In the end, I think the number of vocabularies will grow. And they should all link to each other.
Exactly.
I think that's the only way. And also by letting the number of vocabularies grow, you get kind of, well, maybe like competition, it may be different efforts by different people. Will get different quality of the results. Hopefully the best qualities will, well, something like that.
So we're addressing that in this workshop with the mapping session. So.
Yeah. Yeah, standards. How and why the new standards should be created. Hey, time for food.
Okay, so we can break for 45 minutes now. There's lunch, I guess, at the back. I'm thinking there must be bags of things in there. Ali, do you want to have any comments about this afternoon, or shall we wait till 1 o'clock?
Damien, do you want to do my presentation?
Oh, you know what?
No, we can have lunch first.
I totally forgot.
No worries.
Oh.
What you almost ended, so.
Oh, hey. We're gonna be pressed for time this afternoon, so let's have a shorter lunch, and yep, I would love to have you talk. Right now.
Right now?
Yes.
Okay, it's okay to share my screen?
Yes, I think so, depending on what plugins you have.
I'm also in a Zoom meeting, so.
Oh, I see. Share that way, share. Okay, sure.
Turn your microphone on, and turn that sound off.
Right.
I think Damien, you first have to stop sharing.
Okay, so that's that, and I will stop sharing. And go over. Now, are you, if you could share, yep, or I will.
Yeah.
Thank you, co-host.
Accept everything on Zoom to be allowed to start sharing my screen.
You should be now. I just gave you co-host.
I'm sending all my data to the US.
Audio is on. Share my screen, my desktop. And now you shoot.
And
there it is. Okay. So I'll keep it short so we have enough time for lunch. So I'm presenting some insights today on the ComFocus project, a 4-year EU Horizon project, which was a community on food consumer science, and mainly efforts was on standardizing how food consumer science research was done, and also standardizing food consumer science data. So they were harmonizing self-reported measures. So that means like a survey. So how do we ask for age? How do we ask for gender? And how do we ask for all kinds of concepts related to food consumers? So how food neophobic are you? So that kind of stuff. And we're also harmonizing emerging technology data. So heart rate measures, EEG, virtual reality, XR, etc. for doing that, for the data, we developed an ontology that will come up later, and we're also making a knowledge graph based on the ontology, based on the data that was also recorded during the project. It's all fair, and we also did some things with the emerging technologies, so bridging sensor-based and traditional consumer science approach. So the more old school surveys with the newer technologies like all kinds of sensor tech. There it goes. So that was our whole process. We had a scientific community, which would make all kinds of different concepts. So sets of questions or guidelines on how to use emerging technologies. And then we had the social researcher who would pre-register a study, create a questionnaire in this case, implement a survey, and validate it via the whole tool suite we developed, which basically looked like this. So we had this whole, we made this application. I'll zoom in a little bit, which is basically, I need to go there. It's basically a library of all kinds of questions. So for example, we have all questions on, let's say, sex, gender identity. And this was where the scientific community agreed on. And then we have these questions and definitions. And it's also what was used in the ontology. With all the classifications, etc. And a researcher could just basically select all these kinds of questions that he wants in his survey, link it under his survey, and then perform the survey. So that could look like this, for example, all different languages. And this one is in French. And then the researcher could perform the survey. And at the end, by adhering to this process, all data would come into the right format so that you could directly import it in the knowledge graph. That was the idea. So this is how our ontology looks like. So we have a lot of questions basically in there, harmonized questions which were approved by a scientific community. All kinds of different questions, multiple choice questions, single choice questions, etc. This is how it basically looked like in the ontology. So we have the respondent, the Homo sapiens, who was answering some questions, sometimes about a food product. So that's also where the link to FoodOn was. The Homo sapiens had some individual human behavior. That they had the link to PCIO. And the Homo sapiens could also play different roles. Could be the consumer in the case, could be a researcher, could be a respondent. So main lessons learned is that food consumer scientists are a bit stubborn. So we were expecting a lot of data to build our knowledge graph, but data was coming in quite late at the end of the project. So one of the lessons learned, we should have started earlier with making synthetic data to start building knowledge graphs and learning about how that worked. So that was one of the main lessons learned. We needed to convince food consumer scientists to structure their data. I showed you the tool which they could use to make their surveys quite easily by selecting components. They didn't want to use it. They just want to use their own good old Google Forms or Microsoft form to make the questions. So they typed over all the questions and did a data collection their own way, which made it quite hard to make it interoperable again, because we've made this whole system. We linked all the concepts there. We had our URIs linked to it, but that's something we needed to do at the end. So at the end, what we did, we gave them an Excel file with a template in which they needed to select which question did I use.
I know that informatician.
Glad
to see the real life.
It was the real life. So, so in the end, we came up with an Excel file where they filled it in with a template and we did some checking there. And also, some lesson we learned related to FoodOn, because a lot of these questions and emerging technologies were on a certain food product. And we wanted the researchers to select the food product they did the research on. So for example, if they did research on a certain type of ice cream, they should go to OntoB, find the relevant type of ice cream, fill in that code to FoodOn 00123, and add it to their data. They didn't manage to go to OntoB and look for the relevant codes. It was too hard for them to find the relevant one. So that's something we did as researchers, as more information science, this oriented researchers later in the project was a lot of manual work. So lunch, basically.
Thank you. Thank you for emphasizing my project even more.
Yeah. Yeah.
Did you find any
No, so actually within the project there were about 80 open call researchers. So they were all like postgraduate researchers who got funding to do research, and they were also adhering to these guidelines and also using these kind of data to using these questions, etc., to do their research. So that's the data that came in. So in the end we got 40 something data sets from these researchers, which were incorporated in Knowledge Graph.
New data.
New data. Yeah.
Project.
Yeah, there's all collected during the project. Yeah.
No, why didn't you use old survey data? Something like from your
Why didn't we use it? Because I think the main goal was also to standardize the way how questions were asked. So also the harmonizing of the survey components. So there's a lot of work going into that.
But this work you have done, harmonizing questions.
Yeah.
Data for survey, questionnaire companies.
Yeah.
You have the question and then this researcher can pick them to build
their own survey and also build some
That's
customs.
a good point.
Yeah. Yeah, so that was actually one of the main goals of the project. So now this was a whole library, and it's one thing it is in our system, so researchers can use it and can reuse those components, and they're also building like a book of all these harmonized measures.
Then the difficulty was to convince them to use in the real research process,
Yeah.
let's say, to annotate the data and to have the whole information
Indeed.
included in the
That was indeed quite difficult to convince them to use our tooling, and yeah, they're used to Excel and they're used to Google Forms. That's yeah.
And you want something.
We're trying to. We're using some force.
Because
Yeah.
they have their own reason.
Yeah.
It is not informatics.
No.
It is all other reasons.
The data structure was sufficient.
Yes.
Yeah.
Like you didn't need the full ontology in this case, like the structured data that had like just the ontology, which is kind of what
No, we basically just needed the question ID they used, and then we could fill in the rest for them. Yeah.
Right, so you
Yeah.
ended up making a structured data.
Yeah, that's what we did. Yeah.
Because you have some keys.
Yeah.
already in place.
Yeah.
Okay, so hi, I'm Damien. Good to meet you.
Hi, nice to meet you all.
Right.
Yeah, I'm Themis, and this is Dimitris from the Athletic University, both of us. We work with Ali on the EcoReady project, and we're sorry we couldn't come there at short notice, but I assume it will at least it will be interesting to talk even that way. So Dimitris, when you're ready, Dimitris can start a presentation on what our project, what EcoReady is about. I don't know if you already talked to Talia about it. And then we can discuss about the possible coalitions, especially on the ontology parts. Dimitris also is a PhD candidate in the topic relevant to large language models. So he works on the semantic part of it, and we would like to have some more integration with the knowledge graph, knowledge basis part of it. So I don't know, Damian, Ali, would you want us to start?
Yeah, actually, we had to make the session a bit shorter. Therefore, I will just spare a couple of sentences about EcoReady and then ask Dimitris to go directly in details. EcoReady is a food security project. We investigate in a big consortium, 4-year project, European Horizon project. We investigate how climate change and biodiversity loss affect food security. We use AI, we use scenario modeling, and we use contingency planning. So we are bringing all these tools together to develop an observatory. This observatory is bringing data from living labs. We have 10 of them all across Europe. Each one of them has different type of data. We are getting data from EFSA, for instance, as well. So we need to harmonize all these things together. Temis and his team has already developed a prototype, and I'm just trying to interfere in their work, like, hey guys, a lot of things is coming. I am afraid it will not be effective, so maybe we should be doing something. And I heard they already have some plan for it, and I was very happy about it. And now let's work on it together a bit more. Thank you very much. And now Dimitris will tell us about his work.
Yes, nice to meet you all. I'm really happy to have the opportunity to talk to you about our project EcoReady and how we can also integrate maybe ontologies to help us achieve the project goals. Let me first share my screen. Okay, do you see my presentation?
Yes, we do.
Oh, perfect. So we will see a few things about the EcoReady Observatory, some demo with some of the main screens till now, and I will also talk to you about some of the capabilities of the project. And we will focus mainly, and this is where we want to discuss more, and we want your help and contributions about the semantic search direction, especially in the food security context that we work in this project. So let's start with a brief introduction. EcoReady is a European initiative that focuses on monitoring short, medium, and long-term drivers impacting food security. It brings together a digital observatory to provide policymakers, farmers, and researchers with real-time data-driven insights, as well as a network of living labs to capture on the ground agricultural and environmental information. So EcoReady aims to create a sustainable and resilient food supply by leveraging technology, AI, and stakeholder collaboration. And we could also add here citizen collaborations, because this is a main goal of the project, to become as broad as it can be. So in an environment where climate change, biodiversity loss, and various socioeconomic factors continue to challenge global food security, EcoReady tries to offer real-time insights to help regulators and policymakers anticipate and mitigate these risks. One of our key aims is to use AI-driven early warning system and AI to develop scenarios to support data-driven decision-making for policy-making and industry leaders. We have the observatory, which is the main core of it is the core of the project and our platform for real-time monitoring and doing analytics within the EcoReady environment. This platform is designed to process vast streams of data from multiple sources, including climate models, biodiversity tracking, satellite imagery, and real-time reports from living labs. Let me say a little bit from a technical perspective. We won't focus on that, but we have an infrastructure that utilizes Apache Kafka for real-time data streaming, Flink, which is a very powerful system for real-time processing, and also a Cassandra database for efficient storage and quick reads of data of the system. This setup ensures that the platform can handle large-scale data at high speed. Also, a main aspect of the platform is that it is API-driven, and which allows researchers, policymakers, and stakeholders to seamlessly integrate the data and read the data into their own systems and workflows easily. A main goal also is to achieve interoperability. No single, as we know, a single platform isn't able to solve every problem, but being open and connectable and be have the ability to add more data or to send the data to other useful platforms may help to create a better environment for food security and better analytics on this domain. So let's see a little bit, some things more about the Eco-Ready demo and and especially the dashboard, which is the main interface of the platform. We will see how users can access some key metrics like climate conditions, crop production statistics, and other things similar to them. Also, the dashboard, we want to support real-time alerts and risk forecasts to help all the people that take part in the food chain to know the possible risks or alerts that may happen. So we want to have the dashboard and not only a platform that takes data and shows them in a raw format, because it is important not only to have data, but to turn them into actionable insights. With this in mind, we will see some of the main features of the project. So we can use the dashboard for food system monitoring. This help us track climate metrics, crop yields, and commodity markets. And the data integrated also from the Living Labs, which is a very important thing for our project, can serve us with real-world data that provide ground-level insights about many different products that the Living Lab support. Also, we have data visualization in interactive maps that help us display the information in geospatial layers and highlight the differences between different places. For example, different countries or regions inside countries about the prices of products and similar things. And also, a very important thing is the AI analytics that we want to integrate in our platform, which can help us to forecast short-term risk and support scenario-based planning, helping the policymakers, which is a category of people that our platform aim to help, and also businesses to make more informed choices about the food security sector. So, as we have said, we have real-time market and production trends that may contribute in the food security aspect. We also have geospatial monitoring with proper heat maps that visualize food production costs and other things corresponding to the food chain. And also we can help scientific and policy decisions as we can create early warnings and alerts with the dashboard, and so it can be a very useful and versatile decision support tool. Now we have some of the screens of the dashboard, the home screen, for example, that where we can see the Living Labs and some of the products which we have now in our prototype, because we are now in the phase of having a prototype, as Ali said before, and we want to integrate more and more capabilities and products to our dashboard. Also, we can, for example, see a product overview here that gives information about the production in EU generally and specific countries of olive oil is this example. And also similar screens with trends about other products, we can see here. Also, a visualization of geographical layers that we can see, where we can see about different products, prices or production for different years. This also can help us to have a more accurate historical view of and how the trends go from year to year for different products. And also we have a living lab screen, which is the data I have told you on the ground, data from the ground from our living labs that are a very important aspect of the project. And we can see, for example, here is some climatological weather information, we can say. So having the data is really important, but another critical component of eco-ready system that is something that we will work on the next period is the searchable depository of the eco-ready. It's not about presenting the data. It's not only about presenting the data in a static dashboard, but we also need to have a robust search and retrieval capabilities that can let users explore data at a granular level. So the challenge here is to use contemporary technologies to create a scalable index that can search and retrieve semantic information for the food products of the platform. Let's think about some queries. I'm sure you can also think about, but as an example, some examples we can see for which country has the largest productions of olives, or what are the fruit products of wheat and which is the largest in terms of productions, or what is the average price of tomatoes in the countries of Mediterranean. Every question is maybe simple, but for a system to understand it and try to get the correct information, the correct data to give the necessary information to the end user may be more or less difficult, and it depends of how the question, the query is said and how difficult is it. So first of all, what we need to answer these questions? We need data sources for our depository. We need reasoning and have logic to understand what the users want to get as information, and also in this and to this end, LLMs can help us, and also we can we want to be sure that the information we give is as accurate as it can be. So to this end, ontologies can help us. We think, and I will want your opinion, we think that ontologies can help us to make the information more consistent and be more sure about the answers of our system. So, as I assume you already know, ontologies are standardized vocabularies that define relationship between data concepts. By employing ontologies, we can bring structure and context to otherwise scattered information. I think FoodOn is a good example of an ontology, especially in the current domain, that can help into this end. Ontologies, of course, can help in various ways in AI research and policy making to structure and connect diverse data. So how we think, what we think about ontologies in eco-ready? We think that they can offer better data integration, so we can unify information from different services that we have in the project, living labs, IoT, satellite data, external data sets from other sources. Also, they can improve traceability and categorization by enhancing food product classification and monitoring, and moreover enable AI decision support. As we have said, they can help LLMs, for example, and other machine learning models to improve risk assessment and predictive analytics in our project, and also to support interoperability with the alignment with existing databases as FAO, Copernicus, and other. We have talked already about LLMs, but in case we don't, we can focus in case we don't have know so much. But I think it's like a common ground nowadays, more or less. So they are advanced AI models that are trained on vast amounts of data and enable natural language understanding and generation. They are used in multiple aspects of today in many fields. Especially, they can help in data processing, decision support, and automated insights across different industries. Also, a very important thing and a key feature of the depository that can help, that LLMs can help on that, is the conversational AI, which, with other words, is the capability to handle a dialogue and answer in a more humanized, if I can say it like that, way. Also, they can help in predictive analytics and knowledge management. So, as I have said, we may want we could leverage LLMs in our system to help us with data categorization, maybe, or for the conversation to have a more accurate and friendly environment for the users to search our depository, and also for the auto-summarization of complex studies so policymakers can quickly grasp essential findings. So we have LLMs and methodologies, and we think that both they can help us. So why to combine LLMs with methodologies here? Ontologies impose a structured framework on data, as we have said, but while LLMs handle unstructured text with remarkable flexibility. Merging this capability can allow us to transform raw data into structured knowledge, first of all. If a new document mentions something particular, the LLM can parse that text and map it to the correct ontology class if the LLM already has the knowledge of the ontology. Also, we can enable intelligent querying of data, so the users can ask questions in natural language, and LLMs can interpret the question in the context of the underlying ontology and return precise, relevant results to the end user, and also provide context-aware insights when the system because when the system is aware of hierarchical relationship, like width of, for example, is a type of grain or something like that, it can offer more nuanced responses to queries, improving everything from decision support to compliance checks. And for example, we can say that it could help search for hidden allergens of food that in the food labels may not be referred clearly, but from the connections between which the ontology indicates, it may be more easy to find something that possibly is a hidden allergen in a packaged food. So, to conclude, of course, as we said, ontologies can provide structured, standardized knowledge for the food systems. The AI and especially LLMs, we think, that can enhance decision making by automating insights and queries. And the EcoReady Observatory, we think that is able integrate these technologies to support real-time food security monitoring and better support for the end users of the system. So we would be very happy to collaborate with FoodOn and generally AI researchers to this end. So I want to thank you for your attention, and I think we can start with questions and a discussion generally about what we have what I have presented to you already. So thank you very much.
Thank you very much, Dimitris. It is quite good overview. And do you have any specific first, I can ask if there is any comments or questions or relations you can imagine. The tricky part we discussed with Damian before was the food security aspect or climate change. So it is equality is quite broad, and we were looking for ways of making it more concrete, maybe, or identifying subcategories of the work that can be achieved. Do you have what technologies, what ontologies do you use, Dimitris, or is it still a plan for now?
You mean about the depository?
I mean, do you use FoodOn, for instance, or how? Because
I think we took a look in the FoodOn ontologies, and I think that as we talk about food security, and FoodOn is, I think, has done a remarkable work on this aspect. So I think that we can leverage FoodOn with the help of LLMs to interconnect this the different the data from various sources on the project, and help us have better results and better insights to them.
Question. So when it comes to climate change, you're looking at the effects of change in agricultural process and different kinds of plants being needed. I presume, let's just focus on climate change. I would imagine what you're interested in is how sectors of vegetables, commodities are doing in the face of temperature and drought and other factors. So one is just being able to generalize from this or that kind of tomato being sold to a general notion of tomato. So in the one direction, you're trying to do broad reporting about entities at the top of the, say, vegetable hierarchy. But on the other hand, you'd be interested in cultivars, because what's the response to climate change? It's planting more hardy or different drought-resistant plants to see how they're doing. And that's sort of the micro scale where you would want reporting on success, say, of some new cultivar. What's your ambition in terms of this detail? Where is what scale what scale are you looking at in terms of reporting the relationship between harvest and environment and planning?
Yes, I understand. Yes. Look, from our perspective, as we are mainly technical partners, our main work is to offer the models to the domain experts to help them.
Exactly what Dimitris says, because this is a big picture question. It's a very interesting question, but the thing is really that we have to have some input, especially from policymakers, in order to decide on what level we want each layer of information. So probably we need information in order to have the climate mitigation and the climate adaptation plans, because this is the main, the main different plans that the platform is going to support are these types. But in order to understand if we have to do it for all kinds of tomatoes or for subtypes, this depends. And the project is going to support from high level. That's why we also have data from from large organizations, until ground low level, the data from the living labs. But this depends on the area of expertise. An interesting also outcome here, since you mentioned it also, Damian, and by the way, an outcome that we found in the ontology is the thing that we have food products that come from other foods. So let's say that we have a food product that comes from wheat, for instance, or a tomato sauce that comes from tomato. This part also is something that to be molded effectively requires possibly a knowledge base, and the ontology can help us on that part. That was our initial thought. So if I go back to what Ali asked also, I think the best question to ask after the video's presentation is if you feel that this makes sense, more or less. If you feel that this plan that we have here to combine the LLM with the ontology would bear a good outcome for EcoReady.
Yeah, I'll comment on the food composition part, tomato sauce and tomatoes, the connection. So FoodOn doesn't really have a connection between the listed products. Once in a while, you'll see defining ingredient as a relationship between, say, tomato sauce and a tomato, whatever the taxonomic name is. So that's a whole area where we could perhaps use LLMs as in a recommendation system for adding on the appropriate axioms for our multi-component foods to determine the relationship between the ingredients. FoodOn can't say anything more than that. Like, defining ingredient means that this entity wouldn't be what it's called if it didn't have the defining ingredient in it. Beyond that, FoodOn can't really say anything. But to that end, there's a drive now with a number of projects to come up with an ontology-driven recipe system, which would cover ingredient lists and percentages or ratios. So, but that's different. Anyway, we would be interested very much in getting into FoodOn, the very defining ingredient part, as axioms built right into it.
May I ask a question just for my understanding? So do I understand correctly that in fact, using the ontologies, you try to do a kind of query expansion on the large language models? Yes, do I understand correctly?
Yes, what we want from the ontology is to be like, I could say, fact checkers, or to give a better perspective to the LLMs. The LLMs are really good at generating things, but the hallucination phenomenon is common, especially in models that are not so capable sometimes. So having something like a ontologist that has knowledge, which have knowledge that is accurate, all the ways, it can contribute very much to this end, to have more accurate responses to the final users of the dashboard. Themis, if you want to add something, feel free.
No, I think it's exactly what Dimitri said, more or less. Practically, what we're trying to do is try to lead the LLM to avoid mistakes and provide the correct answers by giving it some facts, some knowledge that's already there. We cannot leave it totally free because it may answer the weird things.
So adding some knowledge to the large language model based on the ontologies. Yeah, okay. Yeah, then I understand it better. Yeah, okay, thanks. Yeah.
Can I just ask a question?
Yeah.
Because you asked the question which ontologies
because I don't understand in the presentation to what extent you are already using ontologies, because I don't understand when you speak about interoperability and then you speak about the dashboard, and I don't really understand what is behind, because I think the dashboard is just visualization of data. And I don't understand how you are managing the interoperability between heterogeneous data, in fact.
Let me just make a quick summary of how we're standing right now, because Dimitris showed you a demo of the dashboard. Underneath the dashboard, what we haven't showed you really is the database. So the database is a large infrastructure that has all these heterogeneous sources of information. It has Cassandra DB and Kafka on its core, and the point is that it can detect, it can receive inputs from different types of streams. So we have data from FAO, for instance, like for different vegetables, different fruit, and different products, etc. Or from the agri-food data portal. We can have different, and of course from the living labs that Rimini said. This is the database right now. The dashboard is the first, if you like, the first visualization and interface layer for anyone to just explore the data. But we would like to build something even stronger, because it would actually be nice to have a dialogue with the data and say that what I really need to see is this specific area, and I want to zoom in on that and say that what happens to the tomato right now in Spain, for instance, or and identify different points in time that may be interesting due to climate phenomena or something. So more or less, that's where we stand right now. We have not built an ontology, and we have not integrated the ontology yet. Right now, our search is a simple, mostly lexical search, maybe with some synonyms. But the point is, we search for the tomato. It shows us the area of that tomatoes are cultivated. But the point is, we would like to have something a bit stronger than that, and to do so, and say, for instance, that how are the prices of the tomato sauce affected because of the drought that happened last year there or here. That's another level of reasoning, more or less.
Thank you.
And if you look at growing crops at higher temperatures or droughts, what data source do you use for that? I think from FAO. Is that the EcoCrop data source, perhaps?
Yeah, right now we haven't integrated still all the different data sets. We have integrated the crops production, the crops prices, these numbers, the crop yields for some products. Now the next big thing that we want to include is weather data. And after that, hopefully some biodiversity data also. We try to cover all pillars of the project. It's an ongoing project. We're currently, let's say, in the middle, right in the middle, I think of it. So,
you need a data source with growing temperatures for crops. I could provide that data source.
That's perfect. Yeah. Feel free. It will be very helpful to send us an email along with Ali also. That's
use for me.
We are working on we collected EFSA data as a data pool to be integrated. We are at the beginning of the communication with Temis. We have started this disaster database creation for trying to understand its effect of the disasters on food safety and food security. Temis only know we will be working on it. We have not done anything, and we have not really finished anything. It is our plan for this year, and Santiago works on it. Where is Santiago? Yeah, so we are indeed bringing a lot of data sources together and trying to see how they would be best connected. And the point that brought me to this, okay, we need some sort of organization and Temis and Dimitris live in this thing a bit more than me. We got sample data files from 10 living labs, and each one of them has a different name, local name. We could not understand it. I thought maybe we need a bit higher level view for harmonization. And we still have 2 years in the project. We completed actually Timus and his team completed the implementation of the database and how the data will stream and how the labs will contribute data, what kind of screen we will have, what are the user requirements. So establishing this base was quite hard. Now we have the system working, and now we can really think about how effective is it, how connections can be better. Therefore, it has been a great moment to bring all these pointers together. We can have 15 minutes more. Do you have any additional points, Temis or Dimitris, or I would ask what would be the suggestions to focus on Thursday morning? Actually, we will work on the equity all day on Thursday, and we will be identifying ontologies related, like from the very basic ones to more broader ones. What could provide us a bit more formalization in this data variety? Another one that comes to my mind, evaluation strategies for LLMs plus ontologies, because LLMs are great tool when you don't have any detailed information. But if you have a detailed information, you can combine them to maybe decrease their errors. So trying to find the balance between detailed orientedness and the generic overview will be quite interesting. I am more an NLP guy, so therefore I am happy to see this kind of investigations, independent of their success or not. I find it quite fun. Anyway, these two would be my highlights from this discussion. Any other point or suggestion as a task?
The data harmonization, often ontologies swoop in maybe when one party has an obligation to report data to another. But here you've got this case where different data sets are coming in, which may not be quite related to each other. So you're not really looking for harmonization directly between the data sets, except on little contact points, maybe. Is that right? But is it that you're creating a schema for each of these incoming data sets? Because if you're like not just downloading the data, but also creating a bit of a schema for what each field is like, then maybe there's an opportunity to add on an ontology layer whereby the fields and the categorical values are mapped to ontology terms. Is that the vision that you might have? Sort of.
Yes, yes, I agree with you that we will going to have, and we already have various data set that it is not sure that everything can be connected together. But working on schema for the data that can be connected in a way, in a meaningful way, it would be really helpful for our system and could provide more useful insights about it. Let me give you an example. We have a product from a living lab that the living lab can provide us data from the ground of this product. Also, having data for this product or similar products from other sources and connect them together in a meaningful way can contribute. We think that can contribute more to the information and the knowledge of our project.
Defining layers sounds reasonable, because we don't have, as you said, and we don't have the power to create everything really in an organized way, but we have connection points, and the project focus on a couple of crops. We are open to include data from as many as possible things, but our focus is a couple of them, only wheat, tomato. What else? The common ones, wheat, tomato, anything else? Yeah.
Yeah, practically it's it's Living Lab has 5 products, so more or less they have similar products. So it's the wheat and the barley also are the two more common cereals. Tomato is very common. Also, I think another vegetable I don't remember now. The point is, of course, what we're trying to do. If you would like to do it for any product, and then it would be overly ambitious. But we go one step at a time. I think the hard part, if I'm allowed to make a more general comment here, the hard part here is to try to get each data set and turn it towards the correct direction, towards the direction of the ontology, and that's a part where that is already difficult for a lot of people, that are not ontology experts, and that's the gap that we have to bridge within here. And hopefully that's why we think that LLMs can bridge at least part of that gap. Because of course, if any part of the information is correctly identified, correctly instantiates the ontology, then it's easy to get the advanced reasoning capability. The hard part is just getting all this information out of the Living Labs. I think that's how we're going to approach it more or less, and we go one step at a time, meaning that, of course, some of the data sets that we have are more close, are better fit for the ontology, more or less. So we go there first.
If you can, we will connect Timis and Dimitris on Thursday morning to our track.
Yeah, so Ali, sorry. So the plan for Thursday, more or less, you would say, is to get feedback in a more structured approach, like specific questions to work on something.
We can decide now, and until Thursday, we can exchange a couple of emails. I have 2-3 people in my team, like Santiago and Osman coming as well to this track specifically. And we will search for possible ontologies, for instance. We have a preliminary plan like this, because we don't know much, what are the availabilities, how they can be connected. And we were waiting you to come and tell us, okay, LLM aspect and the integration was something we did not plan for. But now seeing it, I can say evaluation can be one possibility, working on how to evaluate it. But anything you can suggest in your pipeline to be optimized, or you may need information or an overview. At the end of the day, we want to have a couple of pages of pointers, maybe a plan. We will keep working on it maybe a year or more, and you will be in the lead because we will hand it to you or benefit from what you do. We can find the way, but we need tasks to work on briefly. And we have tasks if you don't have. So therefore, your suggestion to meet Thursday morning to crystallize it is a good thing. If you have a survey, we can ask the people to complete a survey if it is a couple of minutes. Maybe
Okay. We can also discuss it, yeah, if you want. I would like, if possible, just send us this plan that you have more or less for Thursday and some examples, so that we, from the other questions, so we see how we approach this. Okay, Ali?
I will send it tomorrow, and
yeah, perfect.
because I will not travel to Wageningen tomorrow. Sorry, guys.
Sorry, and what?
We try
Perfect.
to make it as specific as possible with Camion, so we can invite anybody interested in this line. We put a couple of lines in the organization document, and now we can be a bit more specific. And if any of you has any time, more than welcome, or pointers or resources, it will be really helpful.
Yeah, just a quick question. I don't understand if you are product specific or not in your approach, because you mentioned wheat, barley, tomato, and another one, and also byproducts. So I think it is important for your market, for yield and market trends, to know how many products are derived from the main product or not. I don't understand. What is your scope so far?
The problem, we are trying to cover everything that is affected by climate change. But the advantage, we have already chosen a specific wheat, really wheat.
Okay, yes.
And we are trying to go as deep as possible about wheat.
Just as a use case, let's say?
As a use case for scenario modeling, for crop yield forecasts. It is all about, mainly about wheat, but each living lab has additional crops as well.
Okay.
So we add this information. And if they don't provide us anything other than meat, we will not tell them you are not successful. Such a balance we are trying to find. I will send you our generic points. Now we get good inspiration, I think, about LLMs and ontologies, and maybe we can make it even more like we can create new options. We can have a broader view and really document a couple of pages. If you have any material, please share it with us. And in any case, even we are not very specific, if you are interested in food security, we will sit Thursday morning between 9:30 and 11 to really discuss a bit more in detail.
For your market trends, are you modeling consumer demand as well, or is it just kind of the production and yield?
We are using magnets. It is equilibrium modeling technique for taking account all these variables. Better people working on it, working in economic research people, and they are really taking into account all these aspects, not just the crop yield. Its relation to the demand and consumers and a lot of things. Therefore, I say we are trying to cover everything, but you can't finish everything. So we have a couple of lines that we are really finishing. The rest is additional information, and we are just putting it in the observatory, and we hope we can increase its utility of this additional data using additional techniques. Good. I think this is it from me. Dimitris, anything from you or from the audience?
No, that was interesting. Thank you.
Thank you very much, Demis.
Thank you very much. Thank you very much for your attention and your contribution in the discussion.
Maybe food safety session, if you want, you can listen in. The Zoom session is open for additional participants as well. And the food safety one is a bit more specific, really technologies, but it is all food safety.
Thank you very much, Ali.
Thank you. Thank you very much. Thank you all.
Thanks. Ciao, Dimitris.
See you.
Bye.
Yeah. Ali will be up shortly. We're just finishing off a break here.
Yeah, no worries. I'll wait.
Okay.
Hi, Alessio.
Hi,
How are you doing?
fine, thanks.
I am.
Hi, Ali.
Hey.
How are you? How is going the hackathon?
Yeah, it is a great start. We are having a great overview from many projects here. And now we are having you with a lot of food safety content. I haven't heard from Bobby's, so I will ask you a couple of sentences about a broader view of EFRA.
Okay, or if you want to. Okay.
I will start. You can and feel free.
Yes. I have prepared some slides. If it's okay, then I will share them.
Yes, please. So, hi again, everybody. This session is for the food safety aspect. We are working on EFRA project. It is European Horizon project again. It's open. It is what was EFRA? I forgot it.
Extreme food risk analysis.
Extreme food risk analysis. And now EFRA platform is being developed. It is functional, and Alessio leading this effort. I asked him what he's doing about this linking, and I know we have a lot of work planned to be done for semantic linking, ontology development, and he has a great developments, good systems really working, not just talking about. And I will leave the floor to him to tell us what is already implemented and an additional system that is really extracting information on food safety hazards. Floor is yours.
Thanks for the introduction, Ali. Nice to meet you, all of you. And I'm sorry I could not be present physically. I would have preferred, but it was not possible to arrange it for me. And I'm trying to share my screen. I don't know if you are seeing it.
We see it now.
Okay. So as Ali introduced, we are working together with Wageningen in EFRA project, which aims at applying AI techniques to the analysis of food risk data. So the idea is to then this is declined in the project in different use cases, but the general idea is to gather different signals from a variety of sources and apply AI models in order to estimate risk related to food safety. In this short overview that I'm going to present, I want to share with you one particular use case, which is the analysis of food safety incident reports, which are documents shared by different sources, usually public sources related to food safety like EFSA or other governmental bodies and agencies related to specific food safety incidents. And here we will see the what was our aim at the beginning of the project and what we have obtained so far. Our goal was and is to extract knowledge from a different set of unstructured data, usually textual documents, but they can also be forms, so semi-structured data as well. And our aim is to identify entities, to classify contents, to find to links together entities, and basically extract from these mainly unstructured data a set of what we called knowledge nuggets. So pieces of structured and linked information. There is a simple example of a food safety incident report. And what our aim is to extract for each of these report a set of properties, let's say, and whenever possible, linking them to existing resources like external ontologies or taxonomies. And for two main reasons. One, to well, since you all work in the knowledge representation field, you know this very well, to speak a common language across the different use cases and models and applications inside the project, and linking the extracted information to existing knowledge repository in order to expand and increase the information, the features, and the properties of what we extract. And this would allow us to will allow the algorithms that will then try to extract, calculate risk or extract insights from this repository of knowledge nuggets, using properties that are not directly in the content that was analyzed, but are come from linking them to external knowledge repositories. We didn't start from scratch, but one of the partners of the project shared some historical data that they collected during the years that was already manually annotated using a custom classification they developed internally. So one of the first tasks, we will see it later, was try to map their custom classification to a set of standard taxonomies and ontologies. So the first thing that we created was, our idea was to create a custom, very small conceptual model that represent, in this case, the food safety incident domain document. We have a food safety incident that is about some food safety hazard. So the coordinates in our analysis are the food safety hazard mentioned in the report, the product mentioned in the report, the producer, the location if it's present, and so a very shallow top level representation, and linking whenever possible to public ontologies following the linked open data principle. The one, and we will discuss this further in the open discussion points. The main design of a formal conceptual model inside the project was to develop a food safety hazard thesaurus. that is a simple SCOS ontology that represents the main concepts related to food safety hazard. So food fraud hazard, biological hazard, physical hazard, allergenic hazard, chemical hazards, and set of subclasses is the depth of this classification is 3. And many of the concepts that are represented in this thesaurus can be found in other existing resources like FoodOn or Agrovoc, but we could not find a single comprehensive resource that would accommodate all the concepts that we needed to represent the data. So the first task that we had during the first year of the project was to map the annotation from the historic data set to this new to the EFRA conceptual model. And in order to do so, we experimented with an architecture that is similar to a RAG. RAG is retrieval augmented generation, where you have a large language model that interacts with a knowledge base, usually in a database or a search engine, in order to retrieve the relevant pieces of information and then compose a final response to the user query. In this case, what we had was the label describing the hazard, or the label describing the product category. And we wanted to find in a set of resources the potential candidates describing that that could be the map for that label. Is basically an approach for ontology mapping, in this case labels from a free simple taxonomy to a more structured resource. The preliminary step for this, of course, was to create a search index with the resources that we wanted to use for the mapping. So the FoodOn ontology, the Agrovoc thesauri, then there was the thesauri that we developed internally in EFRA, and then classification from GS1, which is a global product classification. So here, anyhow, the first step has been using this approach to map the labels and transform the original data sets in a data set annotated with respect to the new conceptual model. But this was a first tool for a batch analysis of an existing data set. So how can we obtain the same result for a live analysis of new documents? And so this was the works of the last semester in the project, reusing and enhancing a bit the tool that I described in the previous slides. We created an agentic semantic annotator where the goal of this agent is to annotate a food safety incident report with respect to a set of domain knowledge that again was analyzed, enriched, and indexed in a search engine. In this case was Elasticsearch used, and then describing a set of functions that interacts with this search engine as tools for an agent. Just maybe I'm giving something as known for everybody. Just a simple introduction. With certain one approach that emerged in the last year has been the LLM agents, where which is a paradigm where where the LLM can interact with a set of tools or functions. You provide the agent with a description of a task and a description of the tools he can use, in this case, were function to get the hazard candidates, the product candidates, and the related concepts. And then the agent analyzes the text, identifies from the textual contents the hazard and the product, and then use the tools to get a set of concepts as candidates to represent that specific hazard or product. And then the LLM selects the one that is the best fit. This, let's see if it works. Yes. Can you still see my screen?
Yep.
Okay, this is a data set of sample, and we can choose one of the examples. If we want, we can modify it to test, but here we can select which is the LLM that we want to use for this operation. And then we launch the analysis. And the system produces a summary of the document, identifies an hazard, and maps it to this is the EFRA food safety thesaurus I mentioned before, and then finds a set of related concepts. Here the ontology in the knowledge base are KEBI, which is FoodOn, and Agrovoc, and the GS1 global product classification. And so the system tried to find at one hazard from the food safety hazard, one product from the GS1 product classification, and a set of related concepts for both of them. In the explanation part, it describes why he did what. And that's it. That's the demonstrator on this part. We are still, this is the first version. We are still working on adding, let's see. Okay, so this was a backup video in case it was not working. The next step on this activity are the creation of a gold standard in order to compare and evaluate a set of different LLM with respect to the task. One of the, let's say, of the features of the EFRA project is that we want to try and experiment green AI solutions. So taking into account the computational resources needed to perform a certain task is an important feature of the platform we are developing. So we want to test and assess the different models to find the optimal balance between KPI for metrics like precision, accuracy, and the computational power or costs associated to the execution of the model. And so we are creating a gold standard, and then we are integrating a set of on-premises model like Mistral, Llama, and DeepSeek. This is the activity for the following part of the project. And now some discussion point that I already briefly mentioned before is that we developed this thesaurus, internally developed in EFRE, this thesaurus, because we could not find a complete and structured coverage of the topics and concept that we needed to represent data. Also because we started from an existing data set that was already annotated with concepts. And that's why this part is not represented using an already existing resource. That is what ideally we would have preferred. And so as a discussion point to you, and we created this little resource that is functional to the project and the analysis and the demonstrators, but it would be more interesting if we can manage either to integrate this kind of resource into an existing resource like FoodOn, of course, reviewing, enriching, and modifying it as it is needed, or publish the resource as it is with a set of same as links to the relevant ontologies like Agrovoc and FoodOn. These are my question to you. I would be very happy to welcome any suggestion and feedback on this point. And with this, if you have any question, I'm happy to try to answer them. Otherwise, I leave the mic back to Ali.
Thank you very much, Alessio. It's quite interesting, quite exciting to see it is really working. And it really provides a good point to discuss, like what can be the best next step, especially from we are trying to understand the food safety aspect, and FoodOn provides a lot of food-related aspects and some preliminary projects before internal ones and external ones on food safety. I would ask the audience.
Yeah, I would say many of these concepts are present in FoodOn, but they are not grouped and structured together in a way that was functional for us. But maybe this is the case. I mean, a resource cannot be tailored to all the use cases and needs in the world. It might have to be a bit abstract and general. I completely understand that. This was just my feedback from what we used in the project.
Interesting.
Thank you. I'm Magali Weber. I'm from the INRAE Research Institute, and thank you for your presentation. And as you mentioned that you have to build a thesaurus in SCOS, I was just wondering why first, and then perhaps just to develop your point to the question you were asking. Perhaps what you did is just a concept scheme to gather the information which is already in place, but not arranged as you need it.
Many of the concept in the at the highest detail level, all the leaves in the tree. Many of the leaves in the tree were present in FoodOn, but they were not aggregated along the dimension that were because it's in some case it's possible to identify the most fine-grained information like metal fragment, but sometimes it's not possible, and it could be enough just having something more general, like in this case, foreign body presence, or for another topic, chemical hazard.
So it's depend on the parent classes mainly for the inference.
Yes.
I guess I'd have some comments about the whole socio-technical side of this, that sway decisions about how the ontology is managed into the future. So one thing, of course, is funding. If your funding runs out in a year, then you're not a good candidate for for creating a new ontology. But the more
I agree. That's why I would like the best solution for me. It would be if we manage to give an input and a prompt to organization like yours in order to enlarge their resource, taking into account some of these considerations.
Yeah, so I guess so two other aspects show up in your project. One is how mature is it? Are you really feeling like you need to add a lot more terms, and it's going to be years of work adding more detail and modeling more dimensions of it? And that question is connected as well to how much of this is an interagency effort? Like, are there other agencies that would be equally interested in the food safety area that would want to partner with you in that? Those two things together really argue for having your own ontology specializing in food hazards, as the multi-agency part provides the security going into the future, as well as the consensus about how things should be labeled and organized. So that's my first response without having any commitments on the FoodOn side. If it turns out, though, that your ontology is very mature, the terms aren't going to change that much. You see your curators going in there a few times a year to add a few things. Then the argument for having it as a separate domain may be not so strong, especially if your curation team is a little, say, unreliable or unpredictable in terms of handling the ontology technology. That's an argument for actually taking your content and moving it into, say, a broader like FoodOn ontology. So trying to be open to understanding where the energy is around this work.
And let me reverse the question. Would the FoodOn agency would interested into expanding its knowledge base and adding this kind of structure, concept, scheme, whatever will be the technical solution chosen to represent this kind of concepts?
Yeah, so just point blank, sure. Sorry, I have a cold right now. But are there other organizations that would want to be equal partners? So you get into looking at what does it look like to be part of the FoodOn curation team, dropping in and out. You know, we have a call every 2 weeks for an hour discussing new terms or new branches or ones that need to be fixed. We're aware of problems around the hierarchies and existing content, but not all problems. You clearly have outlined some other areas that need improvement. But it's a scoping thing. Do we, the rest of the FoodOn curation team, really have the skill to properly manage a food hazard ontology, or should we really be advocating for experts to form their own ontology curation team, maybe with a simpler editing context and so on, that they can really work on their ontology directly without involving a lot of technology, say. There is one other thing, the technology thing. Yes, we are OWL ontology. So we would either way, we would need to convert, say, your schema into
Actually, it's in Turtle, it's a SCOS ontology.
Which?
It's a SCOS ontology.
It's a SCOS ontology I developed in Turtle, but I mean.
And it's very interesting because I'm doing the same thing. We have a SCOS thesaurus, and then we have a planning system to have some whole classes connected to the SCOS concept. I'm not an informatician, but I do know that this is the way we are doing. And so my first question was, do you need also to manage the language with your thesaurus, or you are not only in English? Because I guess that SCOS it's easier to manage languages with SCOS.
Yes. The thesaurus we developed was just in English because the data set we worked on was mainly in English. I completely agree that for a more complete representation, it would be much better to extend it to more languages. For the application purpose of using an LLM, it doesn't really matter because the LLM can understand the different languages. So you can provide the document, the food safety report in German, and then he can choose between the concepts, even if they have a description in English. And another disclaimer is that I am the real expert on food safety hazards are our project colleagues of Agronow, which are the ones that provided the data. I work more on the AI and IT side of the project. So we use this knowledge to do tasks. We apply them to use cases. So the conceptual structure of the thesaurus comes from the expertise of Agronow, not mine. I helped in the technological part in transforming it into a SCOS, but the real description and the labels and this and how it was structured, it doesn't come just from me. It was a joint effort, of course. And yeah, if this would be taken on, I think Agronow is the partner in the project that would be most fitting to take the ownership on this and in the curation of the resource.
I'm curious.
Verification. Agronow is the company in Greece coordinating EFRA, but they are interested and they did good amount of work because they have commercial interest in it. But any ontology developed or any, we have the right to say this is our IPR. So they are not the decision maker in whole output. There is some mechanism to negotiate it. So therefore, I would not say yes. It should be in synchronization with them, because in the scope of the project they are the coordinating entity. But at the end, there is many other configurations possible.
I'm just quickly, it's really neat to see the LLM. I don't know if you're using Spires or Dragon AI, Spires stuff or some other tool, but the RAG approach. It's really neat to see that at the product analysis level that you showed there. And also, you're saying that you actually used a bit of that to build the concept hierarchy. How did that test out with the experts? Did they end up agreeing with the titles of the categories, or did they supply you with an initial hierarchy, or how did that work? And what was the
the agronomes supplied us with a hierarchy. Well, actually, we extracted it from the data, and then we revised it with them. And so the labels and the hierarchy comes from them, that are the domain experts. Then this just having the labels is not enough if you want to build a search engine. You need a bit more data. So what we did was to take this, let's say, a bare SCOS with just the pref label and adding a set of alt labels and a definition. The alt label and the definition were generated automatically using an LLM, and then they were reviewed by domain experts. So and they were not changed much. They were quite good. It's also true that many of these concepts are not complex, like chemical hazard or presence of listeria or foreign body fragment. So they were not, let's say, it was not an hard task for an LLM to provide a definition of the class. And then, yeah, what I find what I found very interesting in this application, let's say my research interest from PhD onwards have always been a mix of semantic web technologies and natural language processing. So I often worked in project or with clients where these two domains were close or intersecting. And when you have a big ontologies with thousands of nodes, many of the classical approaches for classification or for NER are not so performing and quite challenging from the computational point of view. And I was positively surprised how easy instead was to have something running and working. Surely it can be improved, and sometimes the answer is not the one that a domain expert would have chosen, but overall the KPI are quite good. And this technology seems to offer a solution to deal with such huge networks of interconnected concepts. When you have a thesaurus or a taxonomy that counts thousands of nodes in a standard machine learning approach, you would have to either partition and have a specialized classifier at each level, but then you enter in the problem of underrepresentation. Certain classes are much more represented, so you either have to undersample or you create a giant big classifier, but you have more or less the same kind of problems. Basically, when the nodes are many and the data is not balanced, or you don't have any annotated data, because if you have annotated data, even if it's not balanced, something is possible to do. If you don't have annotated data and you have to create it, it's quite costly. This approach gives you an alternative that it's easier to manage.
Perfect. Thank you very much, Alessio. We should continue on EFRA Wednesday, holiday. And you and many other people who are interested are more than welcome to join us. We can make it a bit more concrete. We can proceed about the possibilities. Now this is the food safety session, and please stay. We have 3 internal projects we want to present.
Sure.
And Sander Third. It will give you a good overview of what is available around here and how can we collaborate maybe. So.
Yes, so
Yes.
how should we do? Should I also join the union?
Yeah, if you'd like.
Do you have the link? It's in the document. Do you have the document?
Yes, I do.
Is it up the top?
Yeah, it'll be under the Monday in Zoom.
Oh, yeah, then I should find
Search for SFU.
Alessio, have you heard from Babis? He was interested.
Nope.
We don't hear you. Maybe the connection after putting the charger.
No. I muted myself, and I was checking the email to see if Babis replied, but no, he haven't replied. I also wrote him an email in the past day, which he haven't replied. Maybe he's
off.
He's off. Yes.
Not promised to join. He just said somebody else in the company may be interested. So therefore it is 50-50. If he doesn't appear, most probably he have something else. But just for maybe you interacted, I checked. Yeah, Agrono is doing quite good stuff. They have organized a shared task for extracting food safety hazards. And in this shared task, 100 teams participated from all over the world. These 100 teams really did, we participated as well, Alessio participated as well, many other teams, and it is showing still, we are writing the papers as how LLMs or current state of the art really able to extract these terms from official reports, and all this data was prepared by Agronom. Their experts, their database, they sell it, they make money from it. So they invest in gathering this information. And it is the very first challenge, benchmark, or shared task, as you wish to call it, to do it in a global scale and attract 100 participating teams. So we are getting quite progress and systems together, and it's coming together. I'm happy about it. You see, therefore I brought all relevant.
No.
Okay, great.
Yeah, turn the audio off there.
Off, okay, gotcha.
Maybe. Let's try. Hello? Okay, that's great.
Can the people online still hear us?
Alessio, can you hear us?
Yes. Loud and clear.
An hour and not having the fresh coffee anymore, it may be better if everybody get a cup or try whatever in 2 minutes.
Okay.
Let's continue maybe more practice.
Yes.
Yeah.
Okay. Yes, 2 minutes. We will have a 2-minute break.
Oh, okay.
You just unmute.
Can everyone hear me?
You have to unmute.
Yes, I unmuted myself.
Because I don't, oh, no, sorry, that's that one. That's that one, right?
Alessio, you can hear, right? Oh yeah, you're unmuted. Okay, you're unmuted. That's why I didn't hear it. But no worries, it's fine. Yes. So let me share my screen.
Yes, I can hear. I
Yeah.
just cannot find quickly enough the audio button.
No, I saw your mouth moving. It's fine. Okay. Yes. Hello, everyone. My name is Neris. I work in Wageningen food safety research, and I've been working at the intersection of knowledge graphs and food safety for the last 3.5 years. I will present the merit of knowledge graphs for us and what one of our example works in this presentation. Okay, so why we cared about knowledge graphs in the first place? First of all, of course, it makes it easy for us to incorporate different sources of data and different things about food safety by using identifiers and entities which come from certain ontologies. We also get to provide context to what we're talking about, so we reduce ambiguity. And the last entity is more from a machine learning point of view, because graph data structures also have plenty of machine learning algorithms which build on what we know and helps us predict other links that are not explicitly stated, but are which are likely. And the case study that I will present is building a knowledge graph for chemical hazards in foods. In this work, we aim to link food items to their chemical hazards. And if you're not very familiar with the food safety domain, you can think of pesticides, heavy metals, veterinary drugs, and many other things. These are the things that we consider chemical hazards. But of course, microbes, we don't consider them as chemical hazards. And like our approach was similar to that of what Alessio discussed. We also used LLMs, but we tried to build the knowledge graph using scientific literature. And I will get into the details as well. But before I do that, so just to clarify in your mind, this was just a very, very small part of the early version of the graph, where you see the nodes in red are the chemical entities and the nodes in blue are food items. And of course, if somehow we were able to identify from scientific literature a chemical is known to contaminate a food, then we connected them with an edge labeled contaminate. So now I will describe the pipeline. We first of all collected scientific abstracts that were likely to be relevant to our case. And each of the scientific abstracts, we described what we wanted the LLM to do for us and fed this instruction along with the abstract into the LLM. And for each abstract, we wanted the LLM to return us a dictionary object, where in the key, you would see the food item, and in the value, you would see the corresponding hazard. So a very simple example would be an abstract. If it discusses cadmium in a spinach, we would want it to return something like this. The next step would be to parse these dictionaries and match the foods to FoodX2 terms and chemicals to chemical entities in Chebby. And actually the choice we made about using FoodX2 terms was based on a number of reasons. FoodOn is quite extensive. And by my earlier experience, when we use the complete FoodOn ontology, you have plenty of similar food items coming up in different parts of the ontology, and it gave me a lot of anxiety to manually choose them. So I personally wanted to use FoodX2 where things were defined once. And FoodX2 was also developed by European Food Safety Authority, so it has extra acceptance among our domain experts as well. So that was another reason why we wanted to use it. And differently from most of the people who presented today, the way we matched the food entities in LLM responses was automatic. This also applied to chemical entities as well. So yeah, if we saw spinach, the spinach mapping to a particular URI was automatic. We can also get into its details if you wish. This, yeah, basically we map entities to their URIs. And finally, we expressed all we collected in RDF format. And of course, as I previously showed, the predicate, the edge was contaminate. And as far as I know, there is no predicate defined for contaminants. So I saw plenty of classes in FoodOn, which was chemically contaminated food, but there was no predicate defined for contaminate. So we had to, for now, just create a fake URI and move on with our lives. And this brings me to the pain points we have. The first pain point I would say is we don't have a chemical ontology that is specific to food safety. Chubby's way of handling chemicals is not the way a food safety scientist would look at the chemicals. We look at chemicals with respect to where they come from. Are these chemicals pesticides? Are they veterinary drugs? Are they natural toxins? And sometimes they could even be metabolites. And the way it's basically different. And a source specifying that with a semantic component is missing. Another pain point, as I said, was we don't have predicates specified for contamination. And so we are invested in this field for food safety, but we have a couple of pain points. But honestly, I am happy to see that some people share our pain points, and sometimes we get nice ideas from other people about how we can solve pain points. So it was a nice session. Thank you for having this session as well. And just an obligatory slide showing the parties and projects funding our work. And I'm happy to take any questions and remarks. Thank you. Yeah, Felix.
Yeah, you said you were using your knowledge graph for link prediction tests. Do you have any specific questions how you envision to use this link prediction test in the broader food safety context?
Yeah, so I can already tell you what we did. So it was, of course, you already have certain knowledge of what food gets contaminated by what. And food safety experts are really interested in emerging hazards. So they want to see what will be the new thing that is coming up. And we trained some knowledge graph embedding algorithms. And we tried to see its performance on certain food items like lentil and chicken. And we actually also looked into, so what happened was, most of the time, the predictions it makes not always the best predictions, I would say, because especially when you look at the kind of chemicals that do not occur in the graph much, the domain expert says, yeah, this is a hazard, but I don't know why this hazard would specifically come up for lentil, because the graph algorithm really works with correlations, especially when you only have food and chemical dimension. So it did not work very well, and we will not go down that avenue, but last year it was something that we wanted to pursue, but yeah, it did not work as well as we wanted, at least so far. And
Yeah, in general, you also mentioned it like, hey, you guys do automatic matching.
Yeah.
How have you guys verified that that actually works the way it's supposed to work in your?
That's, yeah, to be honest, I don't know how we should check for it.
Okay.
Like I'm open to suggestions because yeah, maybe there is some literature that I don't know of that does automatic mapping, and
Yeah,
maybe I
or
should.
you do a random sample and just see how it performs in that, of course.
That's-
That you at least get an idea. Of course, there's always edge cases, especially if you use an LLM, but you might have more of an idea of it.
That's random sampling is true, yeah. And by the way, we don't do, like, in case there's that misunderstanding, we don't use the LLMs in the part where we match the foods to their URIs.
No, but you can also have the mistake of the LLM getting the wrong food things out of the abstract itself, of course, or how you're validating that on its own.
Yeah, so actually we have another work validating LLM performance.
Okay.
But a matching thing, like matching from label to URI thing, yeah, honestly, it was yeah, I don't know what the literature, how it is measured in the literature. I don't know. Yes.
My question was more about also the mapping with URIs, because you mentioned FoodX2.
Yeah.
I was just curious, you have just a set of examples, or because from where are coming this URI, because so you need a RGS version of FoodX2. So I guess you find it on the
In FoodOn.
in FoodOn, sorry.
I can show you. Let
So
me.
this kind of begs the question. We know about this in the FoodOn community, but we have that imported branch of EFSA as a subplace in
it was
FoodOn
in the
that's like
exposure hierarchy.
on its own.
So
Like,
it's my question, because I was just wondering about the updating of this rise, because yes, it is from FoodOn.
Yeah.
Because
The
it is
mapping
just the
work-
groups. Yes, it is just the groups, not from the master hierarchy.
yeah, the mapping work from that to normal FoodOn classes is another thing that should
Okay.
be done in the future by
Because,
someone.
yes, no, because there do it does exist a RGF version of EFSA, but it is not maintained. It is the original version. It is posted by the Food Safety Agency, the UK Food Safety Agency, but it was just development. It is still in experimental stage, and so I don't know about the curation of this resource.
So Magali has transform one.
Mm.
And I think you've dedicated an ID for each.
Yes,
That's,
I do provide. In fact, my URIs are already mapped with the FoodX2 main hierarchy. The master hierarchy, not the groups from the exposure.
Right. So you just tech note. So you have actually, I guess we can just cover this in the mapping.
Yeah, this
section.
is another thing to talk about in mappings. Absolutely.
Yes, but just to mention that it is just a way to display groups, and it is not exactly the same in the master hierarchy. Because EFSA is providing different views, and this is for exposure. It's just a view from the EFSA next to main hierarchy.
That's getting at the fact that FoodX2 is a vocabulary for constructing sample descriptions
It's
out
more
of
like a data
several
model.
assets. Okay.
Maybe we should continue with the now. The next presentation.
Yes.
Reload. Computer.
Okay, there we go.
Yes.
Hey guys, online, can you hear us? Folks online, can you hear us?
Yep. I can hear you guys.
You can hear us?
Yep. Yep. Yes.
Yes.
Just share screen.
Yeah.
Is it?
I
Are
clicked.
you in sharing mode? Go
I
back
think
to.
I should be. Oh, you have to make me.
Or can you not just enable sharing for everyone? Whatever. Okay, that's fine. All right.
I'm not very
Try
shy.
sharing now.
I think I just.
Would,
No.
just
no.
like you can do
Entire screen. Yeah.
That's probably
Okay.
easiest. Allow.
I haven't working
Okay.
for a while. Okay.
Yes,
Great.
you're good. Okay, just both.
Thank you. Yes, I think it's working now.
Perfect.
Yes, hello everyone. My name is Susanna Venter and I'm also a data scientist at Wageningen Food Safety Research. And I'm going to talk about our take on the ontology creation that we tried here. So we started off with a problem on perhaps a smaller scale of different food sources being separated. So within our Wageningen University and research, we have several institutes that work on different topics. So Wageningen Food Safety, that's our research, but also we have Wageningen Food and Bio-based Research, WECKER, or that's the former name that is more about economy and social sciences. And all these institutes have their own data sets that are not necessarily connected. And in this particular project, we were trying to somehow make ways to connect those data sets together. And we wanted to do that through ontologies. So yeah, for that, we selected some data sets that we tried to first formalize into some kind of ontology and later put together. And from our side, we quickly discovered that there was no really food hazard safety ontology, as mentioned previously by Alessio. And therefore, we tried to make something that is perhaps more of a data model in the end, to yeah, try to make it possible to connect those ontologies later on, those data sets later on. And we did it from both the bottom-up approach by creating categories based on the entries in the database, and that perhaps had some sort of categorization on their own. And the top-down approach, where we also try to think about the problem at hand and categorize it into abstract categories to structure the data within an abstract framework. Yeah, so we combined those two together. And we, in the end, we ended up with something actually quite similar to what Alessio had, with food items and food hazard items being part of our data structure. Each food item has a food category, and the food categories could come from the database. So for instance, if the data source itself has some kind of categorization, the categorization becomes part of the ontology, and it's inserted like that. And the food items were also categorized through its origin or the source, which could be monitoring data, literature, media, news. Yeah, and like that, we try to make a structure to kind of attach different types of food safety data together. And we tried, the first use case we tried was actually on the RASEF data set, which is a data set of a rapid alert system for food and feed. That is a kind of window on the EFSA website where you can see the current recalls, border control issues with food. The data was collected from different authorities across Europe, and it was also legacy data, which caused problems with consistency because you had some entries that were in other languages, partially in other languages. People had another type
style of entering their hazards, because it wasn't just a drop-down menu. So it made it to a very messy data that we tried to somehow simplify and enter into a knowledge graph. We focused on 3 products here, so lentils, maize, and chicken, and also just parts of the data set. So how it worked was that the RASEF dataset itself had a hazard category, which was a closed list of categories, and a hazard substance, which was people just fill in into a field. From that, we tried to determine what the category was, for instance, pathogenic microorganisms, and within that category, we tried to harmonize it as much as possible to limit the number of subcategories, because otherwise, if you have every simple variant to be a separate category, you get a very long list. So here we tried some data cleaning to do so. Yeah, and like that, we tried to enter the data set into a knowledge graph, but with this, we encountered a lot of issues that I think are common across this thing. And what I find while listening to all the presentations today is that in the end, we all run into problems with, for instance, mapping of ontologies or data mapping. Yeah, that in the end, people try to solve the same problems. Yeah, and I think it's valuable to work together. So yeah, in the end, we came only to the prototype of this kind of ontology. Our goal was to connect the sources of food hazard information to other kind of food data. During that project, it was quite difficult in the end to do that. So yeah, there's also a lesson there. We try to combine both top-down and bottom-up approaches, and we use RASEF food hazard notification database as a use case there. Yeah. So that would be it.
Awesome. Any questions for our presenter?
So those double entries.
Yeah.
You de-doubled them manually.
Yeah. So what I tried doing there is I wasn't using any machine learning, but instead I tried to look into patterns, for instance, of different variants of people writing down a substance or contaminated with and things like that, and just scrape those kind of terms and try to make it as homogenized as possible. Also making everything lowercase, things like that. Yeah.
Also removing parts.
Yeah, but it was quite quite like in the prototype phase. I think you can do much more with it with more time. I was just trying to clean it up as much as possible with the time I had. But yeah, it is a huge data set. So yeah, I don't think we managed to clean it up entirely, but it was just yeah.
One angle on all of this design is comes up with rules of things. So salmonella, think of as contaminating something in all cases. E. coli, on the other hand, has a friendly E. coli and a nasty E. coli.
Yeah.
So that's where we get into the role of something in a certain situation. So it's when we talk about merging ontologies together, and one claims that something's a contaminant of X, that probably works pretty good in the food safety area. There are other cases where we have to switch to roles, which aren't always on, aren't always active.
Yeah.
But they can sit there latently. Yeah, just beside.
Actually, I have a hidden slide where I
try to think about it as well. Yeah, so yeah, also here the food hazards are context dependent. Yeah, when I was thinking about this problem, I figured that with the time we had, we wouldn't be able to actually figure out a entire food hazard ontology. But there are many problems that you can take into account. For instance, something can become a food hazard at a certain quantity. So if you have just a little bit of something, then it isn't a food hazard to someone, or allergens are not always a food hazard. So I think that it would make creating a food ontology, food safety hazard ontology, as it is, difficult or complicated, because you have to take into account the person that's consuming things. But in the end, the project output was not a food hazard ontology as it might be seen, but more of a data model. Yeah.
If you would make a difference in your own material, hazardous enough, you would have to use properties, right?
Rules allow some capability of something or dispositions without committing. That's what it's
So then E. coli has two roles, namely hazardous and
we could apply either of those rules in a certain situation. So, for example, selenium is actually an element that's either good for you or bad for you, depending on the amount. Selenium is used as a therapy in some medical practices, adding selenium, but soils can have too much of it as well. So, ideally, in the ontologically perfect future, you can merge a couple of databases that are about the same thing. One's about deficiencies, but they aren't crossing each other's facts in relation between the food and elements. Only at the data level would you have these amounts that trigger the reasoning that this instance must be a contaminant in this situation.
Yeah, I think how I try to solve this to work more with items and can contain something relations, but think about possibilities. But yeah.
How do I think for your scope?
Yeah.
FoodOn has a broader scope. You have these properties and so between food and contaminants, relation like is hazardous, and the amount. If you see a different solution, I would be interested.
I'm curious. So how I don't know. We can't pull up his slides, but Alessio, how similar? Go back to yours.
Oh yes.
Yeah, I was going to say like these, this slide and the one from him were kind of similar.
Yeah, that's also what I was thinking during Alessio's presentations. While I think we might have also worked on similar data. I don't know, Alessio, if you also worked on the RASEF.
No.
No, but
the data set was the like 10,000 incidents reports annotated from Agronow, annotated using their own internal classification system, let's say. And then the data. And then the ontologies were let's say KB, Agrovoc, and FoodOn were the three main knowledge bases
yeah, I suppose it was still recall information, which is also partially RASEF, so that might also explain the similarity in the end.
Well, yeah, because like so to me, from my perspective, what this looks like is in this domain, you're gonna oftentimes have people reporting on food hazards, and there's like often similar patterns. It's like, you know, they did a swab and they tested for bacteria, or they did some sort of chemical analysis and they tested for contaminants. It's going to be some similar pattern to this. So this, to me, this begs a data structure of like a minimum information standard for food hazards.
Yeah, I think that might be also useful for that. I was also thinking of it during your presentation.
Like FDA and whoever could like it's the same concept of the composition table, making a minimum information
Yeah, I
standard
think actually
that has things like this.
EFSA is also working on standardizing at least not per se the RASFT notifications, but the internal like monitoring data to at least have that standardized more. Or
but in fact, I think just to mention that in fact that's why ontologies are useful. It's precisely because of this context dependency. I mean, you have to exploit the relationships in a way, but it's exactly the question I have in mind. It's how it's because you have the instance level with the property, with the real data, and then how to link to good classes to capture all the context. Just you need to integrate in your in your model. So that's very interesting. But I know it's difficult. But I think we do exist some solutions, but it is really at the RGF level, and I'm not so expert in managing this. It's, you need to integrate all the information in a way, so you are looking at this way.
Yeah.
You need to define roles as properties.
Yes.
Perhaps these properties themselves have properties like quantities. Yeah, I always work in a text file creating ontologies. Whether I create a class or an instance or not. Could also be a property. Although maybe to give properties to a property, I don't know how easy that is. I expect it should be no rocket science. But simply ask it's very simple.
So, right, we should continue with Sander, next presentation.
Yes, so
Safety by design. Thank you very much, Susanna.
Thank you.
Do you have the same charger? Yes.
Yes.
Do you mind if we just use the
yeah,
charger?
no, of course. Sorry.
Keep it.
Yeah.
So
muted,
unmute.
yeah.
Okay. Can the people online hear us? People online, can you hear us?
Yes, I can hear you guys.
Fantastic. Okay. So yeah, just go ahead and full screen and you should be good to go. All right.
Yep.
Hello everyone. My name is Sander van Leeuwen. I'm from Wageningen Food and Bio-Based Research. Oh yeah, I'm from Food and Bio-Based Research, and I will present to you the food safety hazards and process ontology. This ontology is made as part of the project called Food Safety by Design, which I work together on with Bengu. The idea for this project was that the European law requires that food should be safe, and therefore food manufacturers need a plan to ensure that food does not contain health risks. It's mainly due because processes can introduce or eliminate hazards. So food manufacturers need to be aware of what the food safety hazard profile of their food product is. So we needed information on food safety hazards and knowledge on the effect of processes and preservation techniques to control and reduce food safety hazards. Different parties have done research on this, so information and knowledge from different sources needed to be combined. We've gotten information from our team. Our food technology department did a lot of research on it and gathered data on it. And also we collaborated with Wageningen Food Safety Research, who also gathered information on food safety hazards and on how processes affect them. What information should the ontology can also ontology store? The ontology can store the initial food safety hazards, so the food safety hazards of the raw products. Per food ingredient group, we got information for relatively broad ingredient groups, such as cereal products and leafy vegetables, but also for specific side stream ingredients, such as potato peels or spent grain. It can also store information on knowledge rules, which contain the conditions of a process in order to eliminate or introduce a food safety hazard. And I will give more examples later. And also on warning messages when there is an indication for an introduction or elimination of hazards. This is the first part of the ontology where we store the initial safety hazards. So we connected food ingredients, which can be a food material, which are the broader food ingredients I talked about, so such as the leafy vegetables and cereal products, or it is a side stream ingredient. And then every food ingredient contains a number of hazards. And we made the distinction in the hazards between microbiological hazards, which we link to the NCBI taxon ontology, and chemical hazards, which we link to the CABI ontology. The next step was to design a process effect. So this is the format of the knowledge rule. So if an ingredient is processed using a process X under specific conditions, then a hazard Y is eliminated or introduced. The structure of this I designed like this. So in the center is the process effect. The process effect has certain conditions. So of course it needs a specific process, specific conditions. It can also have quantity conditions, for example, a temperature that must be higher than such and such degrees. And to which hazard it applies to, and whether it results in an introduction or elimination in hazards. Note that this is qualitative information that we store. So we don't store how much of the hazards is removed in terms of quantities. So I will be better to illustrate this with an example. So for example, we have this one: somewhere along the process line, cereal products are grilled at 120 degrees or higher. Acrylamide, a chemical hazard, will be introduced as a food safety hazard in the resulting food product. So we stored this information like this. So the process effect is a heating process effect with a specific identifier, which has a condition that it can only be applied on cereal products. The process condition is grilling, and the process quantity needs to be higher than 120 degrees. It applies to the food safety hazard acrylamide, and it results in the hazard introduction. This is a more complicated one because with this there's a formula behind it. This is on the introduction, on the elimination of food safety hazards when they are heated. This depends on the number of parameters of the process. These parameters are put into this formula. This will result in a log n, and this will be compared to a performance objective. And if this log n is higher than the performance objective, then the hazard will be considered eliminated. We store this like here. So this also depends on other things. That the input parameters depend also on the water activity level. So different water activity level require different input parameters for the formula. The formula's values are stored here. And the performance objective is also linked to it. So for the comparison to see whether the hazard is actually eliminated or not. It applies to all heating processes. So grilling was a more specific heating process. This applies to the broader heating process, and it applies to the hazard salmonella, and it results in elimination. Then I have a more sort of simpler example, not only heating, but this is on a high pressure process. This has relatively few conditions because this applies to all ingredients, so it's not a specific ingredient. And it simply says when the pressure is higher than 6,000 megapascal, then salmonella is eliminated. So this applies to salmonella. It results in hazard elimination, and here we store that it applies only to this process, and it needs to be higher than 6,000 megapascal. So that's how we are this far, and our next step would be nice to see how can we integrate this with FoodOn. So I designed the process effector like I showed you, but I would also like to see to make it more interoperable, to see how can we reform this so that it fits with this model as shown here. So yeah, that's so I'm curious to see if we can discuss this week. Any questions?
For verification, when you define a process, you are defining as a class or a property instead of a series of sequence of steps that goes through time to avoid the problem that you mentioned in the moment. Or you are considering different steps that involve a process, or just you are compiling one processes in one category that let's say to specify?
So you mean that we make different processing steps, or yeah. So you can you need.
Because if you make different processing steps, so you can have multiple combinations, and with the way that you are doing that, I think that
Yeah.
You are assigning a new class that is the process, and then the process.
Yeah. So this is specifically for one processing step, and we also made a tool which can query the knowledge graph behind it, and in that tool you can select multiple processes, and you can at the end you get a final hazard list after you apply all the processes.
I was wondering, like if there's a contamination with the micro, if nano has kind of probability.
Mm-hmm.
If you incorporate it,
No. So this is there's some assumptions. So we assume there's indeed a certain uncertainty. Also with the heating process, will salmonella be eliminated? Will acrylamide be introduced? But based on the literature, we assume here that it is introduced or eliminated, or at least that the level is according to the EU standards. When it's eliminated, it's considered to be below the EU threshold. Yeah.
Something is contaminated, like in the production process, for example. So the assumption, like, yes, I will specify in the ontology that there's a contamination, or you don't specify in the ontology because this contamination is not certain.
Yes, exactly. If it's not in here, then it's not certain enough. Yeah. Exactly. Yeah. Because we have the process cutting, but we don't have any data on this. But it could certainly be that during cutting, a hazard can be introduced or eliminated, but we don't have information on that, so that's not stored in ontology.
Catch this information about the confidence level. I don't know if it is possible, but the idea is to keep track of the probability associated with this assumption.
Yeah.
Is that it's also attached to the threshold that is either by the authorities, and then this threshold also not frequent because it changes over time. So that's also another tricky thing to consider. The regulation becomes from also work with the performance objectives.
Yeah.
But so you also have to take into account the date of the data. And so you can really restore it.
Yeah, no, that's a good point that you raise. Actually, we are talking about the follow-up problem.
You have to manage the data that with the date and the history. And then
Yeah.
keep track of
Exactly.
at this time.
Yeah, it's good to keep track of that, and also the sources where does the data come from, actually.
I'm pretty keen to see these examples that you've been creating to see how in the Foundry process model just say focus on the process, then there are certain inputs and certain outputs and energy requirements. Maybe what hazard becomes is the identification of the part of the characteristics of the output. Then you have rules about that.
Yeah.
They're sort of separate from the description of the process. So an everyday cooking process can turn into a hazard, but only because something didn't go right in the output of the process. And so then all your rules are focused on identifying the thresholds of the characteristics or the part of the output.
Yeah, exactly.
Or vice versa.
Yeah, that would be indeed interesting to see how how can we fit it in? Yeah.
I forget, are you going to be around a little bit for the rest of the week?
Not tomorrow, but I'm here Wednesday and Thursday.
Okay, great.
We should have some general vocabulary conditions.
Yes, exactly. Or even probabilities, the characteristic of something in the little foundry land, even the concentration of something is a quality or characteristic of the entity. And so if a concentration of something can be measured in percentages rather than absolute amounts, then you're at your place where you can talk about probabilities.
Yeah.
Any other thoughts, questions?
I made it.
So 4 o'clock, a little after 4, and the sun is out. That's great. I hope to see most of you in 2 hours at 6 at the hotel. Dinner. Hope to see the rest of you the rest of the week.
Where's the dinner now?
That hotel.
Hotel de Washington.
The Wageningen Mountain.
Yeah, very small hill.
You explain, Kai, where?
Mountain, if you have a cycle, so then
Yeah.
it's very hard to.
Yeah, that's become a mountain.
All right, should we, for the people online, should we,
A hole.
for the people online, should we close up the session?
Yes.
So we don't keep them longer?
Right. Hey, Giorgio. Thanks for hanging in.
Yeah, bye everyone. Thanks so much.
Thank you.
All right, we'll close it up today and see you all at 9 a.m. tomorrow morning. Sure.
Awesome. Thanks, everyone.
Yeah, thanks for organizing. Meeting you.